is the new ZVS circuit that I've designed and how it's reacting with the 4-inch sphere. There it is. I'm not getting sound
Wow.
here, Nathan. Um, so there we go. What I was able to do with the new ZVS is reach my 1 million volt goal, and I'll show you which video shows you almost 18-inch arcs from it. This one's a test, so kind of get you an idea what it's doing. And one thing to note about these arcs is they're very purple, whereas when you look at Tesla coils, they're a lot brighter in the white spectrum. They're not this purple, so that's something very unique to this sphere.
It's
Another
the
thing
dark side, Sean.
again.
You have a Death Star coil. It's the dark side.
Nice. Yeah, exactly. So that'll be something I'm exploring. If you could go to the next video, Nathan, that'd be great. If you can, I think it's 17. If you can find 17 MP4, I think that's the one. Okay, so here's some of the O-scope signals that I'm catching. And so that weird bubbly line there is the secondary coil, the sphere, resonating. So you notice on the left, it has this sort of one line, and then it starts to go up and down until toward the right, it sort of almost fills the screen. That's basically, if you could imagine sitting on a swing in the playground and you start pumping your legs. And as you pump your legs, you get higher and higher on the swing. That's what you're seeing there, right there. That's what you're seeing when you go look left to right, where it starts out as a small squiggly line, gets larger and larger as it goes to the right. That entire pulse, if you will, is occurring around 89,000 times per second, just to give you a little bit of context. Now, what you're seeing here is this is okay. So the skinny one is the second, is the sphere, and the larger lines, yeah, the outside of that is the primary coil, the copper piping that you're seeing at the bottom of the sphere. So this is kind of a basic update. I just wanted to share this with you guys. I think if we can click on 17, Nathan, the last video file, that would be great, because that's going to really show where I break my 1 million volt mark.
Wow, this is so cool, Sean.
Thanks. I appreciate that.
Mm-hmm.
I appreciate everybody in the chat. Thanks for listening.
Yeah, everybody loves your stuff.
Sean, there's no numbers on it, so I'm just kind of blindly guessing. So you're gonna have to just tell me what it looks like.
Okay, so there's two videos that are completely black. They show up as an icon that are completely black. Can you see them? So so this is one of them, and we're not hearing the sound, Nathan. Is that possible? Also, can you zoom it in a little bit? That'd be great. So this is not the right one. If we can go to the next really dark one. It's funny how the sound keeps going out. So one of the things here is that the whole room is electrified. That's the one. Thank you, Nathan. If we can zoom back into that one and add the sound. So what you're seeing here is that these plasma discharges are actually reaching a point measured to about 18 inches. So you're seeing it just come right off the camera view. And the camera view is about 12 inches, about 10 to 12 inches. Now, believe it or not, this is the picture one. There's a video that's even more powerful than this one. This is 60 volt input. It's about 2,000 volts coming into it. There's one Nathan that plays, and then it gets clicked off because I blow the breaker. That's the big one. I'm sorry about being so picky, Nathan. You're doing a great job. I appreciate it. So there are 5 videos, 2 black ones, and one of the 2 black ones is the where I reach 69 volts. I can't get to 70. It draws 110 volts from the socket and 20 amps. So that's all my house can provide. Hopefully this one's it. Well, I'll do a better job in naming these, Nathan. I apologize.
No, it doesn't have any names on it whatsoever, and there's 5 black videos. So
yeah,
I'm completely lost on which one you're looking for. I'm just clicking on all of them to see which one does it.
I appreciate that. Yeah, you missed the one I wanted every time.
Okay. There's one. It just shows a fan in the background. Let me see if there's one more. Hold on.
Okay.
Someone called you the next Eric Dollard, bro.
Oh wow, that's such a high compliment. Wow, you guys are awesome. Thank you guys.
Well, I have to agree. You're very impressive work. You got very impressive work going on.
Thank you so much, Ben. That means a lot. You're an inspiration to me, so I appreciate that.
I'm glad. I'm glad I inspired some people. This is cool.
Thank you. Yeah. So I'm about 4 feet away, and the whole room is electrified, and it's I use the word terrifying. That's probably being a drama queen, but it's so powerful. It's just hard to put into words. And when Nathan gets to the one where
I don't think I'm going to find it.
No worries.
Clicked on all of them.
What's the safe distance for that?
So the strange thing about this is it doesn't like to go to ground. So normally when you see arcs like this and sparks, if you bring a wire that's connected to ground and held in your hand, but of course you're holding like an insulated rod, when you bring the ground wire over to any arc or spark, it's immediately going to just drain right into it. It's not going to go flying everywhere like it is now and just ignore the ground wire. But for some reason, and I'm going to show this in next week's presentation, but this electricity really doesn't like to play with anybody. It likes to just be itself. So anything I bring next to it, it ignores. But yet I'm about 4 feet away. I have my fire extinguisher, my face mask. I mean, I'm ready because there's so much power in the room. And the fact that, like you're seeing here, that's probably a 12 inch right there, 10 to 12. It's just, you can't get it over video. You just can't. And I'm going to try really to different angles and see if I can really get that effect next week. But again,
do you think like this could be an effect of you like exciting negative energy to a plasma state, and as opposed to like the traditional like positive energy that we normally excite?
That's a really good question, Ben. That really is. Not
because
sure.
Negative energy just flies through everything. You know, it doesn't follow the conductor.
I mean, it's acting like that. It's very strange. That's a really good question, Ben. I'll have to look into that. In fact, Nathan and I were talking about negative energy before we started this. Thanks for pausing these and running them slow, Nathan. They're really good to really kind of
Yeah.
explain. So there's another couple fascinating points. One of them is nothing's hot. Nothing's hot.
Oh.
I'll run my
It
infrared
has to be.
camera, and everything is basically, warm to touch. The transistors, the resistors are warm to touch, but it's so efficient. The new ZVS, my new ZVS design, it's so efficient that nothing gets hot. Everything is just a fine oiled machine. And the closer I get to resonance, the real true resonance of the sphere, it just grows inch by inch in the arcs. And so, yeah. And I have this, it's kind of fun. When I get in now, walk into the lab, I have the Variac right next to my desk, and I just crank it and I start working. It's flying in the background. It's because I never get tired of it. It's
got the Iron Man music going.
there you go. There
it's the
you go.
real power of the dark side.
The arcs go totally with your voice. That's awesome. Yeah. It looks diabolical or menacing, doesn't it?
It is really cool. It's a beautiful arc. Look at that. It's a brilliant, like it's almost like the Ori Chalcum that we see on the Hutchinson samples,
Yeah, these pictures, by the way, are not doing it the same justice I'm seeing. Okay. And I can't zoom it in, and I'm sorry for that. But I can tell you these things are way more massive than you think they are.
Yeah. I think like maybe the brightness is a little off on the StreamYard.
Oh, no. So, for instance, right now, you look at that, that's got to be close to 18 inches to 2 feet right there.
Yeah.
Wow. Yeah, it's hard to tell that.
That thing is massive. You can kind of see it better when you're watching the video like in Facebook. But yeah, it's like this, I can't really see it.
Anything off the screen is about 14 inches. So you're kind of seeing it go off the screen at the top. And I kept trying to get it in the camera. It's funny because these are still the weak ones.
Yeah.
The big one is where I get to 69 volts. So when I get to 60 volts, it looks like this. Input, 60 volts AC. And then I have a couple diodes into a positive hump, if you will, half the sine wave, the positive side of the sine wave. That goes in to the ZVS. The ZVS then goes right to the sphere, and it excites it through the copper piping at the bottom of the copper bowl. And then that copper bowl resonates with the sphere, and the sphere then outputs that plasma discharge. So it's actually a dance. I think is a way to say it. You have to get each piece to dance with the other one. And this is not yet tuned 100%. Tuning 100%, it just starts ripping the atmosphere all around the room, and I have to figure out how to get further away from it.
You got to contain it, yeah,
and really push it to its limit. So, so that concludes. That's just a little update on some projects I have. This is like 3 of 8 that I'm working on. And I appreciate your time, guys. If you guys have any questions, it'd be great to see them in the chat.
Yeah, we'll put up any questions that anybody has for you.
Yeah, Ben, you want to run through that?
Yep. Let's see. I'm going to scroll up a little bit, see if anybody had any questions.
Well, there's a lot of comments in there about what he did. Show those. I didn't get to see them. I was busy.
Sure, Mr. Lanos. Mr. Lanos. Thank you. Yeah. ZBS is the new Slayer. Yeah, it's a new kid on the block. It's Jacob's ladder with magnetic quench.
We got one from Sears that I've missed. My bad.
Sean, is there a cylinder sphere volume relationship in your ball coil? Cylinder sphere. So the geometry of winding the sphere is that it has 360-degree rings, or you can call them grooves. And there's 100 grooves. The coil, the sphere is only about 4 inches in diameter, and there's 100 grooves that are about 1 millimeter apart or half a millimeter apart, and like 3 millimeters deep. And so then I wind them with 32 gauge magnet wire. I then put it in 2-part epoxy in the vacuum chamber to remove all bubbles. And so that's basically the sphere. And then it has a beginning of the windings and the end of the windings. It's about 2,500 to 3,000 turns of wire. It has like a 400 ohms resistance. It has an interesting capacitance. Oh, I have my stats right here. If you don't mind sharing. It has a 370 milliohms of inductance. It has 68 nanofarads of capacitance. Its resonant frequency is about 90 kilohertz. It has 404 ohms of resistance. That's a lot of wire to get that resistance. Like I said earlier, it's 32 gauge magnet wire. I really tried to use Ohm's law to figure out the voltage of the secondary. If you Google it, there's some respectable physics websites that say anywhere around 30,000 to 75,000 volts per inch if it breaks into the air for corona discharges. But I'm not really entirely sure if that's accurate, because as the air is ionized, the resistance goes down. And so therefore, when 1 inch of the arc reaches out, then the next inch is kind of already ready for it, and it'll take it with less resistance. So my guess is that each inch of the discharge reduces in resistance, and therefore can't be the same voltage that you'll read where, oh, it's 75,000 volts per inch. I would agree that's the first inch, and then it sort of, I guess, reduces from there. But I have some respectable websites also that say you get over 1.1 feet, then you've achieved 1,000,000 volts. And all volts aren't made the same. So when I say it's reached over 1,000,000 volts, I'm saying that there's 110 volts, 20 amps coming in from the wall. Then it's converted to 69 volts AC into the ZVS. From what I can tell, it's about 18 amps. And then it hits the sphere and converts into over 1,000,000 volts. And so if you track that with Ohm's law, my guess is it's in the microamps. At least the microamps. I think it would be dangerous to be around if it was in the milliamps. I would need way larger equipment to get it into the milliamps. So those are the specs. I hope that answers the question. Sorry, it was a bit long.
No, you're good. All right. What's going on, Joe? Gerald? Everybody's here. Victor's here.
Could he repeat the capacitance again?
Sure. It's 68.33 nanofarads.
Ooh, nice.
Yeah, I increased the capacitance when I encase it in 2-part epoxy, and that makes sense. You're mixing a lot of wire with insulators, and so your insulators are acting like a dielectric. So that makes sense. And every formula on the internet that I've tried to calculate the voltage doesn't work. One formula gave me 466 million volts. And so my math is wrong, and it seems like almost nobody knows how to do it. So, yeah.
Have you seen the calculations that Eric Dollard and Griffin Brock came up with on eMedia Press or Aaron's site? Because they did some work on it that involves the velocity factor of the wire, and they reduced the speed of light factor from 300 over your megahertz frequency in megahertz to 297 for the frequency in megahertz.
Okay.
They've got a calculator for coils then from it on their site.
So Eric Dollard is the website?
Yeah. In fact, I have a link to something that might be of interest. We're talking sacred geometry and Tesla coils that comes from Eric Dollard and an individual that he's working with named Dr. Adrian Marsh from England or Britain or somewhere. If you want to see it.
I'd appreciate the link. Can we connect over Facebook Messenger offline? And I'd love to correspond with you.
I'll share. Okay, well, I'll share this link if it's okay.
Yeah, go for it. Put it in chat.
Mr. Lanius said he would love to see a diagram of the sphere if you have one, Sean.
Oh, sure. I'll give diagrams for everything.
Whoops, I think I'm in private chat. Yep. No wonder I wasn't seeing anything.
Hey, Victor, can you repeat that frequency change that you're talking about that Eric Dollard was involved in? I only caught a bit of that.
The frequency change?
Well, what were you just saying about the calculation that Eric Dollard just did?
Oh, when you're converting wavelength and frequency, there's math that's 300. It's supposed to be speed of light, right? 300 divided by your frequency of the band you're trying to make your antenna for. So it's 300 divided by frequency in megahertz will equal the wavelength, lambda. And that's in meters. So then you convert your meters to inches if you're working with inches, or you convert it to your sacred cubits or whatever, and that'll give you the length of the wire you need for your sacred wavelength.
That's
but they took it and used the velocity factor of like coax cable and the power transmission stuff that Eric works with, and they reduced the 300 down to 297 over frequency. But you should probably check their site, and I got a link there. And this guy generates golden fractal discharges with a really high pressure Tesla coil that he has built. That's not vertical; it's linear or horizontal.
Yes,
it's a rather interesting system.
Is it the cosmic coil?
No. This is a totally different system, and so he's hooked up with Eric and the labs there, and it's some pretty cool stuff. I don't know. I mean, you could play the link for yourselves and see what's going on, or because it's like a couple hours long, so I don't think we want to play it now. But golden ratio discharges, and he's got a new one recently in one of their last Zoom calls where he's got a fractal dragon, which is a double-sided discharge showing polar spin activity.
Wow.
Like I say, this is a really high-pressure modified system. This man is a doctor in it, and he's focused on it. He's into Toltec distribution of information and the Akashic and the whole thing. So he's open-minded individual and aware. So,
do you have the name of that person?
Dr. Adrian Marsh.
I've heard of
him at aminnovations.com.
I actually corresponded with him once because I wanted to buy his vacuum diode. That's beautiful, old Russian surplus. And he said, no, you can get it on eBay for $90. But I didn't read what was on his website. I do have a link to it, so I really appreciate that. Thank you.
Great.
Good stuff.
All right, guys, we got to get Gerald in here. He didn't present last week, so we got to get him to present his circuits before we go with everything else.
I'm so excited.
You ready, Gerald? Tell me you're ready.
No.
Why is the camera just showing his head?
All right.
I'm kidding. You know what? I'm not going to bullshit you. I was doing some experiments with my new coil, and I blew like 5 transistors yesterday, and I was so bummed out. until I
no.
figured out what was going on, that I didn't finish what I was supposed to today. I do have the circuit, but I didn't test it because I was just pissed right off. Now that I figured out what was going on, I should be excited. But
Yeah.
I'm still waiting for all my transistors to come in. So I apologize. I mean, I can show some stuff, but I haven't been able to test with the big coil because it's out of commission for the time being. Its bubbles have grown to the size where it's making me nervous.
Where it's making you nervous more than you were before.
Just a little. Because they're now contained and they're growing. And they're not stopping the growing. So what does that mean? I don't know. So
Means the pressure's building.
What's that?
That means the pressure's got to be building, huh?
So I've stopped testing with it, right? And I look back at my notes and there's a way of draining it. I just haven't done it yet. So everything for me got put on hold, and I apologize. I flaked out, guys.
You're
I
awesome.
don't know what else to tell you. I can give you the circuit. I can even show it to you, but I haven't tested it. So
It's Murphy's Law.
That I built. What's that?
Murphy's Law.
Well, I haven't gotten the MJE 13009. I ordered like 4 packs of them, and there's 10 in each pack, and I'm still waiting. I got my meter and I got the scope, but I haven't gotten that. So I was working with what I had to try and show the test for today. And yesterday with this new coil, it just blew everything. I figured out how to, what's the word I'm looking for? Tap the top of the wave.
Okay, real quick. Before we get into that, because I want us to do it, I just want you to show everybody the bubbles on the coil.
Wait, why don't I show you the new video that's on my desktop instead?
Oh, okay.
Do you mind if I comment on these bubbles real quick?
Sure.
So when I was in the Navy, I was stationed on a destroyer, and it was a freshly built destroyer built on the Kennebec River in Maine. And so in order to test the new destroyer, is that they have to do what's called shock trials. And what shock trials are is they light up enough TNT where the explosion in the ocean next to the ship is like 50 times bigger than the ship, the water coming out. And what they're showing is that a direct hit is not as bad as a indirect hit. And the reason for that is there's this traveling bubble under the ocean, and it's looking for something to attach to. And so what happens is after the explosion, the bubble goes to the ship and starts pulsing on it. Basically looks like this picture here. It attaches to the ship and it starts pulsing the ship, and you can see 18-inch thick steel bend like rubber. The whole ship turns into rubber. And then after that, we do our trials. And so when I saw this, I thought, oh no, that's shock trials. Those bubbles are adhering to there to pulse the conductors, and it's just a natural act of bubbles in a fluid.
Again, fluid dynamics.
That's possible. That's certainly possible, except I'm seeing some weird anomalies in these bubbles. Let me share screen and I'll see if
I'll take this one down.
This is a really cool shot, by the way. A close-up shot of your coil and the bubbles.
Yeah. That's for
sure.
sure.
I got this 1,000 times scope. Let's see if I got the yeah. I got this 1,000 times scope that helps me with that. How do I do that?
Oh, I see in the chat cavitation.
There.
Yeah, it's a good word for it.
So this is one of them. Now, do you see this big bubble here?
Oh, wow.
Oh, wow.
If you look on the end, I don't know if you can see my mouse. Can you see my mouse?
Yeah.
Okay. So if you look on the end here, there's lines that look like a reflection that are all coming to this one point. And if you see here, it looks like there's bubbles within this bubble, and it almost looks like they're birthing these bubbles directly. So
It's awesome.
video shifts here, and it goes to the other
Yeah, that's
side.
really prominent right there. I think you're onto something right there.
Yeah.
And it shows the same thing over here, except over here, the bubbles are bunching, and it looks like they're trying to get in. It's
Yeah.
Like it's polarized.
like it's polarized. Yeah.
Can you show the
Yeah.
center of the?
That's so cool, dude.
Yeah.
What does the center look like again?
Sorry.
That center, is that your light ring, or was there a discharge
Yes,
there?
that's a light ring that's there that you're seeing there.
Wow. That's awesome.
So
So
there wasn't a discharge that could have heated
no,
it? Wow.
no, it doesn't get hot. This coil.
And you vacuum
Like,
most of the gas out? That's incredible.
Well, see, now here's the odd part. When I first made this, when I first put it in epoxy, I didn't vacuum it out, but there was zero bubble. Like there was 1 or 2 bubbles. I showed it to Jeremiah Pop, and he was impressed how clear it came out. And I let it set for like 2 weeks before I did any tests, maybe even 3. I'm not sure. And then as soon as I started testing, bubbles started showing up in the epoxy, and then these started showing up because there are bubbles in there that are getting bigger, and as they get bigger, they start looking like this oval one, and there's bubbles on either side. There's multiple spots in this coil that are, or this epoxy that are doing this right now. So it's I don't know quite how to understand it other than possible exotic vacuum objects.
Yeah, I wouldn't be surprised if we found that you were creating some kind of plasmoid structure or, you know, microball lightning in there.
You're muted, Victor.
That's interesting because where's the displacement for, you know, where the bubbles are forming? Where is that manifesting in the system? Is it just pressurizing the epoxy around it, or, you know?
Well,
Right.
if it was
Yeah, where's the
pressure,
material going?
yeah, well, that's the thing. If it was pressurizing the epoxy, you'd see bubbles on the outside, right? Because it would push that pressure eventually out. It's not.
Yeah,
So-
that's why I asked that question. I was like, you know, there should be some kind of indication of that. So there's got to be some form of, you know, material removal. But you'd probably benefit from drilling into one of the holes and seeing what the inside of the pocket is like. Yeah,
consider
because if it's solid, you know, that might be like dematerialization.
Oh,
maybe.
I got a point. Do you
Go ahead,
have
Greg.
any near field sensors, kind of like Sheila uses, little coils or a near field magnetic probe or anything like that you could put near the bubble when you turn it on to see if there's activity?
You mean like a pickup coil, so to speak?
An inductor or magnetic sensor, any probes that you could use to try to find a quantitative difference at that bubble site, a vortex, anything.
Oh, well, there's vortexes all around this coil. Like, there's actually 24. There's, when it's pulsing the primary, I get 12 on the outside that are rotating to the counterclockwise, and then I get 12 on the outside just off from that are rotating clockwise. So it's almost like all the way around it. That's why I kind of wonder if I'm producing those things, because those bubbles are, it said they're getting bigger.
Well,
And-
you looked at it. You looked at it before you ran it, right? I mean,
Yeah, and there was like 0 bubbles.
so I have like a lot of experience working with epoxy, pouring deep epoxy and stuff like that, and bubbles just don't, you know, create or expand
They don't
out of
just,
nowhere.
yeah.
They don't just appear. They're either there or they're not when it's cured. You know,
Yep. And it was
So-
cured before I started experimenting.
the only thing that comes to mind, although the shape wouldn't be explained by it, you know, because it's a bubble. But if you know, epoxy is not permeable to heat, and it is ultimately a polymer. You
But
know,
see,
so
now
it is.
I don't use heat in my system. Well, okay, there's heat in my system, but I direct the heat where I want it to go. And usually I leave it either in the circuit or I'll put it on one of my outside coil pickup coils. The center of it gets cold. And if I put aluminum underneath it, and that aluminum gets super cold.
Yeah,
right?
that shouldn't be happening. That's the point. So however they're forming, even though it's got a little bit of give, I've broken and cracked epoxy before when it's fully cured too. So for it to habitate's a great word for that, I suppose. For it to ultimately form a perfect pocket of a bubble like that, and then even form bubbles within that structure as well, without there being stress, cracks, or anything like that in the epoxy. I mean, it's resilient, but it's not. It is a rigid material too.
Yeah, true. What were you going to say, Vic?
Torsion. Oh, go ahead.
Torsion? Oh, there's a torsion field there. There's actually like
there's two passing. You're going to get many torsions between the fields passing. So that ring of vortices is going to be, you possibly have a focal point.
Well, I do. I draw here, but I just wrote all this on the board. But I have like two torsion fields, one that comes in the top and one that comes up through the bottom, depending how I'm pulsing it. If I'm just pulsing the one, I get the one that comes in the top and it pushes it all out the side, right? That's where I put my pickup coils on the outside of the big ring coil. And then on the bottom, it forms almost like I don't know how to explain that, almost like a double half bubble that goes into the inside, right? But the minute I put the two pulses on the primary and the secondary, that secondary cone forms. And the power doubles inside all the pickup coils. Things start spinning quicker and all kinds of stuff happens.
You can manipulate that field geometry just with the signal a little bit.
Yeah, and my new coil, it does that and a whole lot more.
Gerald.
Yeah, yours is a true vortex coil.
Hey, Gerald, quick question.
Okay, go ahead.
Did you write down the parameters for the epoxy bubbles to replicate it?
You mean how to put the epoxy in and the whole what I used and
Correct. Yeah, and adding
all those details.
wire.
They were written down before any of these bubbles even formed.
Awesome.
Everything I do, I have notes for. I got way too many notes.
So would we be able to connect maybe on Facebook Messenger and share these notes?
I got hacked and haven't been able to get into Facebook for 3 years.
Oh no.
I can't get. I just tried last week. I got 2 of them on video. I'm gonna try the rest of them and get that on video as well. I tried last week. I can't get Instagram still, and I can't get X. I can't get Discord. I can't get none of it. None of it. Facebook, nothing. They'll never send me back emails. It's like there's somebody watching my emails and going,
You got to create a new email account and try again. Hopefully they don't have your IT.
That.
Yeah?
I tried that. Yeah, it doesn't work.
You've been hacked.
I've been hacked hard. I lost my first YouTube channel, my Facebook, my Discord, all of that. And then I got locked out of it. And then I opened up this channel to continue my work. But I haven't been able to get any other social media ever since. It's like somebody doesn't want me to get my message out, which is fine. That's, whatever. I'll pass it on to people that want to hear it. Whatever.
We want to hear it, Gerald.
I'm passing it to you guys. Don't get me wrong. That's not what I mean. But
sure.
Like the powers that ought not be, I would call them. They don't want to hear it. Well, not my problem. I don't know what to say to that, right? But yeah, this new coil that I just did, I'm gonna show testing on it. I wish I was ready for it today. I didn't understand what was going on with it, and I was blowing the 2N0355 Jewel Thief circuit on the plexiglass. Man, blue smoke. And it don't smell pretty, I'm telling you. And I only tested the coil once when that happened. Because I didn't understand what was happening. I made I wrapped a quarter wave into my geometrical coil. And I've only got 12 feet bifilar or trifilar on this coil. And I'm getting 96 volts peak to peak. I'm reaching like 480 volts with my pickup coils, and I'm able to tap the top of the wave by doing that. So it's like I get all the power out now by the way that the coils smell.
Quick question. The pickup coils, are they winded in parallel with the larger coil, or are they perpendicularly wound compared to the main coil?
Perpendicular.
Awesome. That's one of the secrets I needed for trying to replicate your good stuff. Thank you.
Well, these coils seem to push the field out of the side, right? Because it compresses in the middle. There's like a null zone right in the center, almost like a sphere. Because those two vortexes hit, it's like it shoots out a plane in the center of the coil. And by doing that, it enables me to pick up that energy on the outside.
Yeah.
So, yeah.
And so it's perpendicular to that pattern that you just said, where it disseminates out from the center.
Yes.
Fascinating. Thank you.
No problem. I apologize, Nathan, about the circuits, man.
Ian's gonna run you down, man. He's looking for that circuit.
He's been waiting for me. It's all, yeah.
I'm gonna give him your email and let him email you because he's trying to get something done and he just doesn't have the circuit and he wants to get it right.
No!
Yeah.
It's
and
like a race.
He's like, what?
Ian heard I was coming on today, and he's like, Gerald better have that circuit before that guy starts talking.
Exactly what he said.
I can show the circuit. I just can't. Yeah.
Can I ask a question?
I'll bow my head in shame.
Well, at least the cat didn't whiz on your router.
Yeah.
You're not wrong. Well, I did whiz on it. It just pushed water over it. Right? But same effect, I guess.
That cat knew what he was doing. He knew what he was doing.
Maybe.
Love those cats. Hey, real quick, go ahead. Did you say something?
I was wondering if it would be an inconvenience for me to get the capacitor and diode settings to jump off of my ZVS. Those capacitors and diodes to build the high charge.
To swap them out, you mean the ones that? Is that what you're asking?
No, Nathan got a bunch of diodes and built a directional bridge for charging a bank of capacitors. And I'd like to get the values of the diodes, the 1N something, 714s or something, and then the capacitors, if that's not an inconvenience.
You're talking about the voltage doubler?
Yes.
Oh,
The voltage doubler circuit.
I'd like my system to be as close to your guys's for measurements and reference.
you need a voltage multiplier circuit. Is that what you're talking about for the AC flyback? Yeah.
Yeah.
I will send it to your email.
Cool. Okay.
I'll send you the link to my YouTube on that so that you have it and all of it's on there. You can get it from Amazon.
Okay. Yeah, I want to build it and then talk with Sean and thank you.
Sounds good.
Yeah.
Okay.
Sorry, go ahead.
Sorry. Is Ben, did you have an update on your coil real quick? Because these guys are going to go at it. We're not going to get a word in edgewise.
Yes, I do have an update on the coil. If you're a Patreon supporter, you've already seen the video. So here, let me find it real quick. I did find an H-wave in the Fireball coil, but we have a problem, and I need you guys to help me fix it because I don't know how to fix it. So I'll explain in a second. Let me load up the video. But regardless, this is very good news.
That's good.
Yes. Okay, guys, maybe you can help me figure this out. We're at 700 hertz, square waveform. This is around the same range, 800 for the Mark I, that we get over unity production. Now, I increased the gain a little bit, and this is using the transformer method. And look at that, there's an H wave coming out of the fireball, right? There's an H wave coming out of the fireball. It's almost perfect like the other one. Not as perfect, but almost perfect. And we should be getting over unity, but look, as soon as I hit the volume or the power a little bit more, turn up the power to increase to put to the circuit, and it starts distorting. And I'm turning up the power and it's distorting the signal. Look at that. And I finally get enough power to turn this on, and look at the signal, it's completely distorted. Why is this happening? I'm getting the signal that I need to for over unity production with this fireball. It's confirmed. We get the H wave. But as soon as I turn it down a little bit so it's so just slight amount of power. And it starts to form into that perfect, well, near perfect H wave. See? But then I give it a little bit too much power, because I'm trying to put power to the load, the circuit, and it just completely distorts it.
Well, I can tell you what's going on right now.
It's like it can't. Yes,
No.
please.
It drops off. So you're not exactly getting the spike of the H wave. You're just getting a steady drop off like this, right? Like the power is going off, just on a slight, downturn. So as you increase the amount of voltage, you're increasing the duty cycle. So the square or rectangle you get is going to be larger across the screen. Okay. So it reduces what you're seeing. So you have to zoom out so that you can see it, because you're too zoomed in right there. But that's just the duty cycle wave of a DC.
But is this indicator that I'm close to the range that I'm looking for, but not there?
I can't tell till you zoom out on your camera setting when you do it, because that's way too close.
So when I zoom out, I don't think I have a video image of
so
it.
Hold
when I zoom
on.
out,
Let me explain
it is
it.
like a square.
So just let me explain it. Yeah. So what's going on is as you add power, the waves get taller. Okay. And right now they're going out of the screen because they're taller on the screen. That's how the oscilloscope works. So you have to zoom out as you add power. So all you do is back it off so that you can get a little more distance on there, and it'll show the waves a better.
So I did back it up. It's not in the video, and it looks like the signal is like just too squared. But at that, you said what?
That's a duty cycle of a DC.
Can you reduce the amplitude when you get that sort of tall square wave? Basically shorten it, make the wave shorter.
So right now, when you increase the power with the stereo amp receiver by increasing the volume, it just automatically spikes up the amplitude, but then it kind of squares off at the top.
Are you able to reduce the view of the amplitude on the screen so you can see the top and bottom?
Yeah, it's not in this video, but I can do that.
It give more insight into the pattern, the wave pattern. But I think Nathan's right.
Yeah, the wave pattern, it's like when you zoom out, it looks nothing like it needs to be, right? It looks nothing like this. But when you zoom out here at the low power, it looks like it needs to be. It's just when you increase the power, it somehow reshapes the signal. And I'm not really sure why it's doing that, but I have a feeling that we're getting close to the range. Maybe this isn't like my theory right now is that the spacing for the bundle in the coil is just too big, and that might mean our tolerance for hitting that sweet spot is a lot shorter, whereas
which means it's not compressed, so you need more power going into the system.
Okay, that's a good point too. Well, what we see in the Mark I, the green coil, is there's like a fat range, like anywhere from like 700 to 1200 hertz. You see that waveform kind of form and kind of tune into the perfect wave, and then you get the over unity in that range as well. And you can kind of tune in. I think the sweet spot is like around 800 or 1,000 hertz for the green coil, but it's like a fat range. So I'm thinking, since there's more spacing in the big coil, we have less, wire bundle to the size of the coil frame, and we might just have a tighter tolerance for that sweet spot.
So it's going to be in time, Ben.
Yeah.
Hold on. Because, okay, when you measure the distance in between the coil of the green one, right? And in each one, so there's a distance there, right? And you're gaining distance in the orange one. So that distance is measured in time. Okay. It's just how long it takes for each thing to pulse those sections. Okay. So they're this far apart, it's going to be one time for those part that crosses. But when they're this far apart, it's going to be a longer time, right? So that measures in your duty cycle and then how long it takes to get to that second time and it hits again. So that's just kind of where you have to think about it when you're doing this. So you're going to get a delayed reaction compared to the other one, the smaller one.
Right, it's going to be delayed. You're right. And this oscilloscope isn't like the fastest to update. It's not like a really expensive one. It's a real cheap one. So, the display is, I don't know what the frame rate is, but it's pretty low.
Gotcha. Well, I get my amplifier tonight. I bought a new one, so it's coming in tonight. I got my sphere magnet coming in on Monday. So I'll be right up there with you. I'll do a resonance frequency test here in just next day or so, and see what the number is just by putting a 20 k ohm resistor on it on one wire and running it through the rest and seeing what we get. So I'll have a radio frequency number for you.
Nice. Yeah, it's just for anybody interested. This is 700 square that I was using, 700 hertz square waveform, and I was putting just the slightest amount of power in there. So if you're trying to get something like this or replicate this, that's exactly what I did. And I don't know, that's my theory on why I'm not able to tune it yet, but I think this is a good indicator that it can be tuned. Just seeing that little pattern there is just it's a good sign, I believe. So that's all I got.
Yeah, I'll just say from my experience, the bigger the coil, the more distance they are apart, the more power you need for that coil. And then obviously Gerald's crosses each other, quickly, like just immediately on almost all of them. So his power has to be really low. He can't put high power in his without all kinds of problems. So,
right. So it has to, maybe it's just too sensitive. It has to have that low amount of power.
Yeah, as Mike said.
Yeah,
I got
that's what I was thinking when I saw the change in the wave was, I was like, the more you're putting into that wire, the more interference that's ultimately too.
Yeah,
because there's like a fine line when the amplitude starts coming up on it, it projects off, and it's the interference between the two. Well, I'm not saying it is, but it could be the interference between the two lines breaking it down slightly, and the higher you would push it, the more you would see it.
That's a good theory.
Yeah, that was my gut right off the bat, but I don't really, I only know what I know, which ain't much.
Well, I'm sure between all of us, we can figure it out. Like, especially since Nathan has the coil already built now, and it's in the same dimension, the same way that I built it. So we'll be able to crack it.
It's looking good, though, man.
Sorry.
Yeah, thank you. I'm sorry. What did you say, Sean?
Beautiful coils, awesome update. Appreciate it. Yeah, closer wires, shorter wires definitely help because they can act as antennas or receive interference. Also, too, it looks like you have a little DC motor running, that fan.
Yes.
Yeah, DC motors also can mess up or muck up your your signal on the oscope. So
Even with the
good area
rectifier,
to
huh?
Google. What's that?
Even with the rectifier on it, it could still screw it up.
So the rectifier, yeah, is smoothing out the AC, but motors can have a tendency to feed back into your line,
Oh.
and it'll look like kind of a signal that you have. That's why I was asking you to see if you can change the amplitude. So yeah, shorter tolerances, look for feedback in your motor,
Mhm.
are two good avenues.
Nice. I'll write that down. And then, yeah, just disconnect that DC motor and use LED lights for testing it for now, maybe.
Yeah, the LEDs like they did for the load. Yeah, like Gerald
Mhm.
uses. Yeah,
Right.
exactly.
Yeah, because they're a diode as well, right?
Mm-hmm.
Yeah.
Yeah, exactly. Yeah. So I think maybe just keeping it simple, stupid is a good idea.
That way you don't get any feedback and blow your amp again.
Yeah.
Yeah.
Hey, Nathan, quick request.
Go ahead.
Can you double click on the picture of the MOSFET that I had sent you?
Oh yeah. I did want to show that. So give me a second.
Sure.
Because
I want
nobody got to see your board, and I want to show that real quick.
Sure. Thank you.
Just click on one. There we go.
So there's a zoom in on the MOSFETs. The MOSFET kind of fits the whole screen. You see it?
Give me a second. Right here.
There you go. So tighter tolerances, reducing noise is an important thing. So if you'll notice there to the right, the third pin there on the transistor, I put a little ferrite ring on it. And that's the gate to the transistor. It's actually called a MOSFET. What that does is that cleans up the signal that's going in to the MOSFET, because the MOSFET is a hyper fast switch. And I've seen the oscilloscope readings from this little change here. It's cleaned up the signal immensely. And that's why one of the reasons why my sphere is so efficient, because there's no noise on the line from just adding that little tiny ferrite ring on the transistor. I just thought I'd share that.
You
Hey,
put that
real
on the
quick.
gateway, you said?
Yeah, it's on the gate or
Sorry.
yeah, it's on the gate of the MOSFET.
Okay,
Pin one.
the C11 that you see right there. Can you tell them what that's for?
Z11.
C11. Your little
Oh,
you know what it is.
Capacitor.
yeah, it's
Yeah.
a little ceramic capacitor. So normally when you see a ZVS board, you'll have those two fat resistors over there in the upper left. Normally on a ZVS, you only have one of those. So what happens is when having only one resistor and no capacitor, there's a diode over there on the left corner under the two fat resistors. I'm sorry, that's the wrong diode. The diode there, that if you look at the legs of the transistor and go up, you'll see at the top a black cylinder with a gray ring on the right. That's the switching diode. And so that diode is also responsible for giving feedback to the transistor. And so what happens is when you have a ZVS from Amazon, is that diode there doesn't get forward biased. It basically does not do what it's supposed to do. And so it's really frustrating because then your ZVS won't oscillate, and then you'll burn up your ZVSs like candy. If anybody's worked with ZVS boards from Amazon, that's typical. So this little addition here of that little capacitor, the extra fat resistor, they just create a circuit to put like a 0.7 volts on that diode. And then that diode does its job where it then provides feedback between the transistors. And so what the ZVS does with two transistors is one turns on while the other turns off, and then the other one turns on while the other turns off. And so that switching diode is part of that switching process, that oscillation process. Does that make any sense?
Yeah, it did.
I need that schematic for sure, if that's possible, because I'm just starting to work with CVSs, or at least I'd like to. And from what you guys are saying, it's exactly what I need. So
Yeah, that's a cool hack.
Sean has boards for them. Didn't you buy a bunch of them, Sean?
Yeah, so I can send you what is called the Gerber files, and you can upload them to a PC circuit board company. They charged about $2 to $3 per printed circuit board. And then I can send you the schematic, and I can send you what else? Oh, the parts list. So that way you could just go to a PCB site, upload it, pay a few bucks, get the circuit board. You can order your parts on Amazon or Mauser with the parts list, and then you'll have the schematic that tells you what it's doing. I can provide all of that. In fact, if Nathan wants to collaborate after this session, we can put those in the comment section. Nathan, is that possible?
Absolutely.
awesome. I appreciate that. Thank you.
Yeah, it's a really nice looking board, and I love the fact that you can change out those MOSFETs, because blow them up like they're nothing, and I like those little things you just have to screw them in. Makes it so much easier.
Heck yeah.
And Nathan, just to kind of give you a little bit of what's the word, perspective. That sphere there at the bottom of the screen is 4 inches in diameter. That is 0.2 inch copper pipe. It's like air conditioning piping. I got it on Amazon. And so it's connected to the output of the ZVS board, which the ZVS is just a high voltage oscillator. And what it'll do is it'll put out like 500-600 volts at the frequency that's determined by that copper piping and those two white capacitors over there on the right. This is what's also fascinating. Those little tiny capacitors, that little sphere can pump out lightning, and it's a lightning that doesn't want to react with anything. I have tried, and I'll show videos next week where I've tried to coax it to do what normal electricity does, and it just refuses. It's really, really interesting.
Have you ever brought it outside during the beginning of a lightning storm? I'm not recommending it, mind you. I'm just curious.
How to Train Your Lightning by Sean.
I don't want you to get hurt, Sean. I'm just saying, if it's not interacting with anything else, it might be connected to that. Just a thought.
Thanks, Gerald. My wife will like that comment.
I don't want to get you in trouble, brother.
I'm sure.
Okay.
Hey, Bernie.
What's up, Crypto? All right. Joe, it's yours. You need me to bring up any questions, or you memorize them? Are you good? What do we need to do?
Oh, no, I'm all good. Yeah, thanks.
Okay, go ahead.
Hey, everybody. What's going on? Victor, thank you very much for meeting with me, man. I really, really have always enjoyed your stuff in the comments, and whether it was me just chatting back and forth with you, or just seeing your presentation from the last couple of times, man, it's just awesome stuff. And there was definitely something I wanted to ask you that I thought would kind of be interesting. Do you see advantage to the imperial system over metric, given that it's fraction based and given that it's worked out, in twelfths and quarters and 64ths and all that, and how it relates to some of the geometry?
Do I see an advantage?
Yeah.
Kind of see both systems working together. I mean, imperial units is what scientific notation comes from, but yet the sacred units give us the simplest square, circle, and triangle for scaling factors, so that we can create and code these geometries to get us to a number that gives us almost not the exact value. We're not getting exact values out of anybody's system, really. We get super close. Like the speed of light in the land system is not exact, but we get the 186,000. It tells us the clues where to go to seek true And then our measurements get refined by the scientific method where we're using the wavelength of light to do it all. So I see value in both systems because I've got Planck length in inches using fractals, but then I think there's also one that would put it in centimeters and nanometers. So they're both there. It has to be accessible to people. So the inch and the cubit, I don't see a precedence over either one myself. They're both valuable. But the
I
sacred,
think that the reason that I brought it up, though, is because I was trying to research something in particular that I had heard at one point in time, and it seems to have fallen off the face of the earth. It was about how, some of the different like astrological measurements, like to do with the circumference of the earth, the circumference of the moon, the circumference of the sun, and then the distances as they relate to one another, that those relationships and the fact that they align so perfectly and so on, that particular discovery, for instance, only could be discovered in imperial measurement. Like it didn't relate to and to metric, like the numbers worked out differently. So I didn't know if there was any other correlations, between imperial measure and that stuff. Maybe it's, I tried to work some of the math myself, but I literally just became mentally frustrated and gave up. So
I'm not sure, but there is one measure that I found dealing with the Earth and the sun that I found interesting. In Kabbalah, I couldn't find anything in like Godwin's book that dealt with the number 216. And yet, if you take the radius of the sun, not its diameter, but the radius of the sun, and the radius of the Earth's orbit around the sun. Okay, you take Earth's orbit radius divided by the sun's radius, and it'll give you the distance from the sun to the Earth in 216 solar radiuses. And I thought that number just came up cool because the moon is 2,160 miles wide, and then you got these 216 radiuses, and so that's how it fits into my mechanics.
Yeah, no, that actually makes a lot of sense, and I think that's pretty much what I was talking about.
Okay.
Yeah. Yeah. So I mean, that's really, the only question that I really had there. And there was a couple interesting things that I wanted to talk about, though. Nathan, can you pull up that Taurus that I sent you, the animated one?
I like it.
I don't know. Is Nathan there? I don't think he is.
Yeah, he is. He's just sitting.
Oh, he is. Ah, there he is.
I'm here. Sorry, I'm pulling it up right now. I was working.
Thank you, sir. I was like, where'd he go?
That's fine. There you go. That's the one you're looking for?
Yeah, that's the one. So, there was a specific name for this Taurus, but it's basically like a Taurus in a fifth dimensional representation. So, the way that I was kind of imagining some of, this is like that motion, in an upper dimension, ultimately acting upon a lot of the forces that, that we're seeing. Which is quite interesting when you think about it, because that it's sort of my opinion that like this is sort of the mechanism that pushes the fourth dimension forward, and has a lot to do with time and space, as we perceive it. So I mean, do you have any thoughts on something like that, or anything that about the shape at all?
Not that particular one for 5-dimensional. Oh wow, we have a severe storm warning. I knew what was picking up.
Oh, I was thinking, where's that noise coming from?
There's a lot of energy going to get transferred apparently right quick here, and we're getting a wind warning that severe storms going to bring dust particles everywhere. So,
Oh boy.
anyway, no, but I am familiar with a 5-dimensional object that also has a counter. I think in the 600-dimensional thing that Clee Irwin and his group at Quantum Gravity Research uses. a projection of,
Okay.
but it's oh, the book I read. Oh, I don't have my bag of stuff out here. I got a book on understanding this sacred geometry in higher dimensions, and it talks about hypercubes and the simplex, which is a tetrahedron, and it in higher dimensions. And if you take a tetrahedron, 5 of them, and link them all up together around the same vertex, that's the shape of my spacecraft that I want to build.
That's awesome.
It will be a crystal that's tetrahedral, but then there's a small angular gap in the nose, just like the Millennium Falcon almost. In the book, it says that is where the 5th dimension allows time to play. Little gap.
It almost sounds like a double pentadodecahedron.
It looks more like a pentagon with a little gap at the top.
Oh yeah, okay.
It's puffed out because it's tetrahedral. Gives you enough room to put your generator in the center between the 5 vortices and manipulate your. You guys will look at the picture someday. I'll draw it up. But when I saw that shape, and I had already made the shape out of what was it? Galvanized steel. I had already built one to play with, and I saw it in the book, and it said it was 5-dimensional. I bought the book because I had to know how. So that's the only 5D object that I'm aware of can sit in our actual space and be connected to a 600-dimensional higher unit.
Yeah, that does make sense, seeing that it's tetrahedral in nature. Ultimately it would be able to link up and, be part of the bigger picture. So that makes sense. That's very cool.
It also, in my math, when I looked at it, that same object smaller, it told me when I did the math and found unity in 5 different shapes, 4 of them had positive charges and 1 had a negative charge. I was like, this can't be. What could this be? Well, my nephew ended up finding it. It's called a pentaquark.
A pentaquark?
Yes, a 5-quark module. And there's research that AI discovered about the proton that says, hey, we don't think the proton's 3 quarks anymore. We think it's 5 quarks going through this transmutation. And I'm going, oh my God, I have quark the stuff here.
Yeah, mind blown, right?
Right. So
yeah, right. I always like to put a name on.
Focusing on learning and focusing how mine fits Malcolm's.
Yeah. I don't know. I've been thinking a lot about some of the geometries of this stuff lately. And I think Nathan and I were talking the other day, and the most apparent thing just popped into my head, and to what degree it's correct. I said anytime you're dealing with coils, and you're dealing with wire as what you're running your energy through, you're realistically dealing with a 2-dimensional surface. So no matter what shape you bend it into, for what it's worth, you're still dealing on the 2nd dimension within our own, which is super fascinating to think about because it's point A and point B.
Mm-hmm.
I disagree. I think you're dealing with 3 dimensions.
Well, okay. So, how so?
Really tiny.
Well, yeah, the macro to the micro, right? So you're affecting how do I explain that? The wire that you're winding and the energy flow that you're putting into it is affecting on a level, I would say, almost to the Planck scale. Therefore, it's more than 2 dimensions. I don't know. Maybe I'm wrong. Define dimension.
So okay. So I guess let me elaborate a little bit without making it a normal convoluted Joe statement. All right. You have a run of wire that you're running signal through. Okay. That signal is running through a point A to point B. Now, I'm not saying that it's not propagating, and it's obviously how you coil the wire that's going to result in the interactions, but ultimately that wire, the energy on that wire has flow. And it's through the interactions that it meets with other points in the line Okay, that's going to determine the effect depending on what you're running through it, what the shape is, what the distance is, the rate of how wide the coil is, how close the coil is. All those things matter, and if they cross and when they cross. So the point is that you have energy running along a straight line interacting with itself, but the straight line that it's running on is a two-dimensional thing no matter how you twist it. Now that doesn't mean that the effect and the propagation off of it as a result is not a three-dimensional effect.
Yeah.
Okay, but the actual energy running the line is a two-dimensional
I see your point.
situation. Right.
Yeah, I see your point. Yeah.
Right. So, and the reason that I brought that up is because, whenever you're making the different shapes and stuff out of two dimensions, if you want to imagine bringing, bringing the shape and flow, somewhat into something similar to what you're building, let's say, because obviously the shape's going to affect it, but it's going to affect it by its interactions of the shape, not necessarily the shape itself, which I think,
It's interesting.
there's relevance. Right.
Yeah.
So, the way that I'm thinking about it is, how do you take something that's 2D and actually sort of make it 3D, so then the effect then becomes actually higher dimensional? Which
I would go ahead.
Yeah, so I mean, the only thing that I could think of that is analogous to that would be like, multi-channel lines and stuff like that. That's the only way to bring another dimension in, is another direction of flow.
Another direction of flow and layering.
Mr.
And layering.
Right.
Yeah.
Toroidal geometry. With
Yeah.
the toroid, when you think about it, everybody's got a blender, right? When you start it up, what do you hear?
Yeah.
That water's going to gurgle, right?
Mm-hmm.
You are modifying the vacuum when you take a plane wave and start changing its angular momentum. You are modifying the vacuum. You are sucking in air.
Yeah.
So you can make a closed system like the sphere Malcolm system and
Okay.
give those vortexes. You are
Now that's the transition I was looking for. A cone.
I'm glad I could help.
Yes. A cone.
See
right?
the cone? I was working on it earlier today.
This is universal mind at work, I'm telling you.
Yeah.
So now I did a couple of things, and none of it's super interesting, but it's worth for banter purpose anyway, right? So I just have like a literal cone and have my vape that I like to addictively suck on throughout the day. And, I already know what's going to happen. You blow a little bit in, it's going to collect, right? Because the pressure is going to be higher and pushing down on it, and it's a little bit heavier than air, but it's still, because it's vapor, it's still lighter, still wants to get away and dissipate, right? But it'll collect as long as it's within the cone. Now, if you put more vapor and dense vapor, it'll start coming out the little pinhole at the bottom. Now, I took my coil that I have, which again, it's the same crud coil that I've been showing 100 times. It's just this that I plug into my computer and it runs it full cancellation. Okay. But I shoved a piece of quartz in it, right? Now I run it at I was actually running it at phi squared of the vibrational frequency of quartz 32,000 whatever it is
68
change, right?
Crystal frequency.
So right, to bring it down to like more a lower frequency. Did the same exact test, and it pulses little toruses out of the bottom instead of having it be a full drain. So, and that's at full cancellation with an impure piece of unterminated quartz.
Okay, so if you look at cones and you look back into Egypt and the fact that there's a ton of cones that have been collected throughout Egypt, I have a theory that states that the Ankh and those cones were the things that would facilitate a 2-ton stone to be antigravitic. Only because it would create charge separation within the stone and change its polarity so that it would become weightless. Or weightless is kind of the wrong term. I'd say more like its mass equaled its frequency to light. Maybe that's the wrong term. I don't know. I'm still working on it. But,
So,
go ahead.
yeah, so I'm sorry, I didn't mean to interrupt.
I was just going to say those two cones, when you need two to make it work, and they interact. So when they punch at each other, and they create that sphere, and the energy goes out, it goes out to the point of that stone. And what they would do is they resonate that flow or that sound into the stone, and because those two cones would hit, the two vortexes would create that sphere, would cancel out that mass. I'm still working on the theory, but it kind of goes like that. The charge separation would happen within the stone itself. Almost like how a rodent coil compresses the south field into the center, or north field, I'm not sure which it is, and then the rest of it's on the outside, kind of the same way.
So, like right related with where I had left off with Nathan last time, I pondered this whole thing about pressure differential a little bit further, and I realized that that the subjective zero equilibrium of any two systems does not necessarily have to be zero. It's just the zero equilibrium of the two and the differential of either. So, what that means is, you're dealing with anytime you have matter and you have energy, interacting with one another, which is, by the way, in my opinion, it's the only time that either is relevant,
Yeah.
Realistically, it's the interaction between the two, because what happens, in a space potential of energy when there's no matter there doesn't really make all that much of a difference, for purposes of this, at least, I guess. But it's like it's a ratio between the two, and you have, if the energy at any given point, the volume of the energy overwhelms the mass to such a degree, that creates the inner pressure system, so basically you have a collapse.
Yeah, it's part of the mechanism that cancels the mass out entirely. Were you going to say something on that, Victor? I'm not cutting you off, Joe.
No.
Thought just came to mind. There would be a certain pressure ratio to get the vortex to become stable. If you think about it, if you drain the bathtub, there's a certain depth. It's called H, I think sub n is the function, and then there's math for it.
Yeah.
The tub has to be at a certain volume compared to the diameter of the drain to actually get the vortex to form. Otherwise, it just sort of dimples around. So there will be a pressure value.
That's funny.
And that's where I'm going.
Atmospheric to, I'm not sure what all is included. I have to go back, but I've seen that equation in Mathematica.
Okay, and I can confirm that because I've done tests in my old house that had all concrete walls. So the rooms themselves are extremely sealed. And when I was doing tests, there was 4 others in the room. All of our ears popped as if we were walking on top of a mountain, right? And we all had to do that thing with plug our nose and blow so that our ears popped back. And then I shut the system off, and then it popped back again, so that the pressure difference in that room changed due to the electrical that was running in the background. So yeah, that's mind blowing.
Can I?
Yeah.
I took a bath one time
for you guys with the coils, real quick.
Go ahead, Victor.
you know, Malcolm's storm thing where the vortex comes down, but then there's an upward flow.
Yeah.
And that upward flow is what gets recycled. What if we used 2 coils and did Nathan's experiment where he had the 2 charged plates with the little jumper, and we can change which way it goes. We make the charge go from the bottom coil to the top coil. That gives us lift, and when the vortex goes down, that gives us thrust. The system remains stable, and we have forward acceleration like we have never seen.
That's the idea. The only issue I'm having right now is what thickness of plate to use and what high voltage. That's where I'm playing with. It's different than Nathan's, because Nathan's using spinning magnets and aluminum plate in the middle. And it's a different dynamic, right? Whereas mine, I can create the bubble down below. I can also create the flow from up top. I just have to get the right circuit so that everything runs at the same time that I need it to. Yeah.
And we know then that high voltage is necessary, but too high is going to clog the drain. Too low isn't going to allow the big pie to open up to little pie.
Yeah, absolutely. You're right. You're dead on, because I was using 3,000 volts at 30 kilohertz when it first hopped 6 feet. And then after that, I was playing with like 5 kilovolts and 10 kilovolts and couldn't get it to hop after that. So there is a fine line. I'm just trying to find it.
I would think that every build will have its own sweet spot, because there's not going to be any like DNA. We're close. We're all in the same, but no 2 coils will be the same. So we'll all have a different TARDIS.
But they all, if they're all based in the same principle, then they'll all be able to do the same thing with slightly different parameters, right? So we just have to find that, like you said, that fine line.
So this is very smooth segues, and I don't mean to get off of this all too much, but it was on my list of things to discuss today. And I went back and I'd only half watched like some of like the Salvatore Pius videos in the past, but I knew that they were fairly running like a little bit consistent with how my train of thought on the whole subject matter goes, and then I had like pictures of his patents and stuff for like a long time, and like kind of looked at that, and I looked back at his interviews and stuff, and he doesn't really disclose a whole lot about it at all. But
He's
then now what I realized though is that showing a picture and have him discussing basic principle and he said it himself in the interview, he's like, listen, your view, he's like, the people watching this interview, like there's going to be people that can fill in some gaps here, but here were some gaps that I filled in with it, and I'm talking about I had sent Nathan it previously. He doesn't have to pull it up again, but it's the box with the 4 I'll call them transducers for lack of a better way to put it, but basically, I mean, what I did was I referred back to some of the things he said and connected that to some of Bearden's work, and when Bearden was talking.
This is Bearden's work.
This is Bearden's work, is basically what it boils down to. Yeah, but Bearden told a lot more than he did. So
and Bearden goes into like weaponry and stuff like that. That's not my cup of tea. Like I said, I've seen enough death. I don't need it.
Yeah, I mean, but you don't.
Trying to get funding.
But the thing about the weaponry is, it might not be a cup of tea, but when you listen to the concepts, the application of it applies across the board. So
could you imagine you could shut a volcano down? It's about to blow, and you have this kind of tech. You can literally drain the energy out of it and shut it down, and power 5 cities in the process. So why wouldn't you want this tech, right? I don't know.
But when you look at it small scale, you're dealing with 2 high output but low amperage, high frequency scalar propagations. I'm not talking about the scalar itself, because obviously that's contradictory, but I'm talking about the input of what creates the scalar in the first place. You have that directed at each other, but then the piece that I put together was the other two transducers, right?
Mm-hmm.
They're running off the same shit, except it's firing through what is it called? It's piezoelectric, but it's not like quartz or anything like that. I forget the name off the top of my head, but it's like a man-made compound. It's like zirconium lead. Somebody in the chat will probably help us out. Anyway,
PZT,
I'm pretty.
was it? A zirconium titanate or something?
Yeah, that's it. Zirconium lead titanate or titanate. Yes, that's it though. Okay, yeah. So long story short, what I'm gathering between Bearden's stuff, knowing that there's major influence there, the diagram is that, and then what everything we're talking about here, I'm feeling like he's running scalar through one, and then the same exact frequency of propagation through the piezoelectric that's pulsing it simultaneously all at the same exact time. So when you're getting the high frequency and the spikes, it's just spike after spike after spike, and that's what's keeping the power up in that particular system. And the thing about it is very little coils, very little wraps, very compact, this big.
Yep.
If you this big, if you want it to be, it could be as big as you want, but that big.
I can make it as small as a watch at this point.
So,
that's it.
Yeah.
So do you suppose that the piezoelectric is how like Eric Dollard says, to get transluminal, you need to mix the longitudinal, which would be electric, and then the piezo is where we're introducing the transverse and mixing?
But there's a way of doing it with coil system and geometry.
Well, yeah, there's going to be several ways. It depends on what you want to translate.
Mm-hmm.
That's true.
If
That's
you're turning waste to energy, or cleaning up water, or changing your fuel into putting out oxygen, and
it
depends on the transmutation.
You're right. It's a whole tech. Wow.
Yeah, right. I mean, I've been saying since the beginning, there's so many ways to accomplish the same task. I just find that one to be like very path of least resistance. Idea-wise, it accomplishes all of the same things. You're interacting two major potential fields into one another, creating propagation and condensation of energy at a directed point. You're having a return to sender effect that you're redirecting into a center point as well. That's capturing it, and then you have the piezo hitting it, blowing it open. If you have, they're saying, like, if you have a spot, and it doesn't have to be a big spot, we could be talking about a spot that big or smaller. The energy density in that one particular spot overwhelms the mass in the area, creates a vacuum. There you go. Now that's when you get the unlimited energy and all the other effects simultaneously, in my opinion. I think that once you start to get that suck and blow effect out of it, that's it, man.
I refer to it as four-wheel drive out of energy, as compared to natural two-wheel drive on everybody else's.
It's like runaway.
Your idea there takes care of two of the facets Tesla said. The piezo is vibration. The coil is energy. What's the third?
Boom. Done. Chocolate.
He said thinking in terms of energy, vibration, and frequency.
Frequency.
You've got all three of them mixed.
Yeah.
Mm-hmm.
The piezo's the. Yeah.
I did an experiment that I got working once. I haven't been able to get it working since, so it's inconclusive. But I had used a capacitor and a piezoelectric speaker in series with my coil when I was pulsing it, and it ran on its own. I didn't need a battery. The piezo and the capacitor seemed to create its own power source with the coil, but I think it was more the change in magnetic fields happening so fast that allowed it to tap it like a pump. I haven't been able to do it since, but it was a really interesting experiment. I need to
Now
try
the thing
it.
about the tap it like a pump and all that is with that other type of material that I was saying, you know, quartz will become electrically excited when it's in, you know, when it meets resonant, any sort of resonance. And if you put a charge into it, it does put out a slight greater charge. But this other stuff, it's more electrically affected than anything. So if you run a frequency through it, it's throwing off piezo. That's ultimately what, you know, fires it. So, you know, it'd be firing left and right every single time. I'm not familiar enough with the material to really have further comment on it, but that was my understanding in the little bit of reading that I did.
Well, have you seen the work using piezoelectrics where they do time reversal waves? They'll actually send waves of an image into a tank of water with a piezo element at the bottom. And like the tank's at like 10,000 and the mirror is at double that, period doubling. And the wave, instead of going out at the same incident that it came in, it actually follows its entry incident and goes backwards in time.
That's awesome. I heard about something like that. That's awesome.
Now, what would that mean for refraction?
Has he seen my Renegade device?
No, Mike, I haven't seen it. How are you, by the way?
No. Good. How are you?
Hey, Mike.
Yeah. Hey, Gerald. Okay, so my Renegade device is a pulse motor. It's basically a modified Bendini circuit. I don't use MOSFETs. I don't use SSRs. I don't use anything like that. I use a disruptive discharge switch. I modified a 12-volt relay switch that you can buy at Canadian Tire or Princess Auto, you know, the little square ones. So what I was able to do is overclock it by bending the armature a little bit closer. So I use a disruptive discharge. Now, the coil I use is usually a pound or better in mass. My motor kind of runs more or less on the Newman theory. So it is an inductive reactance. But I made a discovery about 2.5 years ago. I had those little wafer piezoelectric, you know, wafers. And I go, what would happen if I hooked that up in series with the coil? And guess what? I got about a 40% gain in power.
Yeah.
Reactive power?
That's awesome.
Yes. It hyper excited the reactants in the coil.
Ooh,
So that was
are you going to
a really
do something?
big discovery.
It's very cool.
All my pulse motors, basically from that day, have 2 piezo transducers. So I'm currently using a 2-inch barium titanate. It runs at 41 kilocycles at 40 watts.
Come on.
So it works amazing with it.
And that gives you high voltage, yeah?
And I've been using it ever since. And
Yeah, Mike, you break it up.
That's how increases the high voltage. Sorry, I'm on the mute there. I find it increases the voltage. It increases the reactance in the coil. And because I'm using the spark gap switch, every time the switch physically opens, the current from the battery feeding the system goes to 0. So,
oh yeah, okay.
I've been running my Renegade device, but well over 6 months old, and they still run. My device will run with dead batteries.
Yeah. You've been breaking up a lot, Mike. I know what you're saying, but you're breaking up a lot.
Yeah, I caught every other word, but I kind of got the gist of what you were saying.
Sorry, I was just looking for a patent to show you, Joe, about quartz crystals. When you put them in a electromagnetic resonant field, they, excuse me, it takes a little bit of time, but they begin to grow and become massless.
They begin to really,
Yeah.
begin to grow and become massless in an electromagnetic resonant field. Now we lost Gerald. We're falling apart over here today.
Huh.
Sorry about that. Somebody was asking me a question I had to answer. I apologize.
Oh.
But yeah, in an electromagnetic resonant field, quartz crystal grows and becomes weightless. There's actually a patent. I think it's T.T. Brown that I think it's his patent. I could be wrong on that.
I mean, in resonance with the quartz, that's the resonant field. It's got to be tuned to the quartz resonance.
I believe so.
Now I feel a little bit better. I was just like in any resonant field. Like I'm sitting there like, how do we not know this?
To the quartz resonant field. Yeah.
Okay, no, that's very cool though. Yeah.
Yeah, Mr. Laney said it was T.T. Brown. So yeah. I think I learned about that patent actually from Terran Earthling. So interesting stuff. And
no, very cool.
If that is true and it becomes weightless, then that goes to the Otis T car system, and he states he learned it from Tesla. In the center of his ship, they thought it was a quartz crystal. They weren't sure, Ralph Brown said, but it came up out of the floor and it would resonate, and it created a rotating field of light within the ship before it worked.
Now, I've heard that same thing before about the crystal in the middle of the ship and no moving parts, just moving energy, visible moving energy. So, yeah, I mean, I've heard that. And it seems like with everything that we're doing and talking about, it's right along the same lines,
Sorry, guys, my computer crapped out on me. Can you hear me okay now?
Much better.
Yep.
Yeah, sorry. Where did I get cut off?
I mean, you were at the tail end of talking about your Renegade.
So what happens when the spark gap switch opens, every time it opens, the current draw from the battery, and it can be a dead battery, it goes to zero. So my draw from any battery that runs this system is in the microwatts. So I've been running the Renegade with batteries have been dead for like 6 months, and it still runs it.
It's awesome. Very cool.
So it just keeps going, and I can dump it into a large, those big blue capacitors. It's like I think the one I had is 80 volts at 12,000 microfarad. So I would dump all that into the capacitor, let it fill up, and then dump and run a 4-watt light bulb. So and it does it continuously, and it just keeps rebooting itself every like 10 seconds. It'll just dump. So yeah, for the amount of power that I'm putting into it, and a lot of people don't take into account time. Okay, you can get over unity from time.
Mm-hmm.
Maybe not at that present second when you're actually charging something. It might not look like over unity, but over a period of hours, it far exceeds the amount of energy coming out what actually I'm putting into the device.
Yeah, it's like what Bedini was saying, right? You're not getting a blast of free energy. You're getting it over time of charging your battery, and you look at the numbers and go, whoa, that shouldn't be, but it is. So,
it keeps running. It just keeps running and running and running and running and it doesn't
It
stop.
fits an ancient parable.
The
The
witch?
tortoise and the hare. Slow
Yeah.
and steady acceleration is better than
Slow and steady.
instant acceleration.
Absolutely.
Yep.
See, I'm a total dumbass though. I say just rip the friggin' universe open and let it all pour out. You know.
Right.
May not go so well. You know?
That's okay too. That's okay too if you know how
Yeah.
to do it. So, yeah. You know,
Hey,
not
Mike.
open up.
All the experiments I do, I still use the same battery, but I'm still the same wuss and using 12 volts.
Yeah. Don't
I
be a
can't use
wussy.
anything more. I'm blowing stuff up, man. I should be
Yeah,
using
like
5 volts for Pete's sakes.
Yeah, to fill these guys in on the little joke there. My Renegade device runs 40 volts and above. More voltage going into it, the better. Like Joseph Newman, his motor ran on 460 volts DC at 50 milliamps, but he was still able to move a rotor that weighed 4,000 pounds.
Yep.
So on 50 milliamps of current, how is he using the voltage to create that current to move an armature that weighs 2.5 tons? So it has to do with energy to mass. The higher voltage, you can get voltage very, very easily. Current is generated in the coil, the inductive reactance. The inductive reactance, it accelerates the electron charge through the coil. It magnifies it. So I suggest anybody who's interested in that, get Joseph Newman's book and read his theory, because he's dead on the money.
Yeah, I was watching his videos when he was still alive when he first came out. Man, can
Yeah.
Salvatore, what was the name? Pius?
Pius?
No.
Pius?
Oh, Salvador Pius.
That's
Joseph Newman.
Yeah.
Joseph Newman.
Yeah, I just wrote that down myself too. Just another rabbit hole to go down.
Yeah, he ran like a 300-pound.
No, way bigger. His largest was 7,000 pounds.
Yeah, that's right. Yeah.
And his system was also reactive?
It was reactive power.
Yeah, inductive reactance.
Yeah.
There's that piezo buzzer, by the way. It's like double when you hit it on a bad frequency, but when you hit it on a good one, you get it up to 100 times. You have to hit it at the right time. It's a timing circuit.
So it changes the frequency and the voltage.
It amplifies your frequency. It basically will take you from 25 megahertz to well over 100. So you're going to be able to pick up a ton of power in that way. It'll also amplify the discharge of a Tesla coil like crazy. So just so you guys know, I just want to throw that in there for you guys. It is an amplification
before you
circuit.
go though, did you hear what I was saying before about the there's the piezo that is hyperstimulated anytime it has frequency running through it. So when you're running a dual scalar setup, and then you're also running this, if you were to run the same frequency at the same length and everything like that through this crystal, technically you should be hitting the peak almost every single time because it's running off the same frequency.
I wish it was the case. They pick up a beat frequency, so they pick up with those little discs. They receive and transmit at the same time. So they always receive the frequency of what's going on in your craft or what's going on in your circuit. Now, in order to hit that at the right time, it just can't be at the low point. So because your frequency always goes up and down like this, if you hit it at that downtime, it'll still amplify, but it's just a tiny bit. You want it to when it gets to the top of the ring. So as it goes small and then it gets bigger and bigger and bigger, when it hits that last height right before it discharges, that's where you want to hit it. And
see again,
theory
mind only coming in here. And so correct me when I'm wrong, but realistically, it should ideally be hit as it's coming off the zero center up, because it's the same frequency. So if you're hitting the go button, you want it to go up and peak at the same time to get the perfect timing.
So what happens is like a gas carburetor.
Mhm.
When you dump too much gas and it can't breathe, and you choke it out,
Poke it
you
out.
get that
Yep.
stalling. Yeah, you get that stalling effect. You want to hit it right as it needs the gas. So right as those cylinders are purring up, that's when you want to hit it right at that peak. Because what happens if you dump it too early, it'll choke and it'll just, the car goes, ugh, like that to you, right? That's exactly
Okay.
what it does with the electricity. So you it's a timing thing, but it's not that hard because it's a beat frequency to your circuit. So,
But it's also an environment thing, is it not, Nathan? Like your timing is involved with your environment. It changes.
it'll change based on the amount of energy in the air, whether there's too much water in there or it's dry. I shouldn't say water. I should probably just say like a fog or something like that, like early in the
Moisture.
morning.
Yeah.
Yeah, it changes the exact amount you get out of it.
Yeah, but if you have a secondary field, let's say, now we're talking about something entirely different. But if you have a secondary field, like a static field, for instance, then realistically it should kind of be somewhat insulated from the outside environment at that point, just based on that static charge. No,
So not as much as you think because they're thin fields. So when you create a Tesla coil field, it's a thin field, right? So things still go in and out of it, right? You can't get that field thick enough. So if you rotate the Tesla field, it gets a bit thicker, but it still allows things to get in and outside the bubble. We don't create an outer shell. Now, if you have an outer shell and you create the field, then yes, it will not affect it one bit.
well, I mean, this thing that we were talking about, I'm pretty sure you could build it in like a friggin' like a steel electrical box, like just a junction box. I'm pretty sure, like, I'm not saying that it should be out of steel, but I'm saying, like, I'm pretty sure, like, that's the situation. You can put a lid right on that thing.
Yeah, so that probably wouldn't conduct the field on the outside well enough to be around it. It would have to be like some kind of a like aluminum material. But if you had an aluminum box, then yes, absolutely.
Sure.
It's just the way that the field works. It's the interaction of it. It has to be thick enough to hold everything in, but thin enough so things can go back and forth, because you're going to want to expel some of the stuff on the inside to the outside, okay, before you amplify it. So,
Sorry.
Yeah,
Well, you need flow through it regardless, because I think that the whole entire principle of it working is dependent on energy mass transfer for that. Because if it's not for that, then as we've said, the ether is something. It's not thin air. It's not like it's coming out of thin air. There's a power transfer that occurs at that point that's giving the extra. So it can't be a closed out block thing where it's just inside of an aluminum casing.
Well, there's two ways of getting, there's probably more than two ways, but from what I've seen, you can get it subtly by pulsing it like a pump.
Yeah.
Or you can crack a hole and it's gonna come through so hard and so fast, it's gonna be blowing meters and transistors and scopes, and you won't be able to control it. When I first found this, I couldn't control a darn thing. I was like reaching 2600 volts every time I turned it on.
I told you about the over unit in my garage. That's how it happened. I couldn't control it. I didn't realize it.
But you get to a point where you use the subtlety of getting that power in, and not that big hammer that's gonna destroy everything, right?
So it's like I said, my theory on that is it's like you have this huge density of energy, and because you have the volume of matter being our atmosphere around it, it's sucking the frigging atmosphere into it and creating energy out of atmosphere at that point, and because it's a cascade effect, when you hold it open, it's just going to continually cascade in. And because the density is so much, and because it's creating more as a result of it, it runs away, is what it is. It runs away.
Yeah.
and that was the whole entire concept of mine and Nathan's last talk. I was like talking about like, you know, you have this single point, it'll run away. My understanding of it though was that as long that if you had it to the point where it had that the incoming energy also had a drain, like a load, for instance, that the load itself would regulate the pull of that. The same as how on a magnetic field, if you need more, you plug, you know, you're putting more in. This is opposite. This is you need more out, you know, you take more out. It's pulling harder because of the load.
Yeah,
you know, but without the
you
load,
don't-
it'll run away because where's it going to go? And if you try to
Absolutely.
hold it, it'll,
So
you know.
Well, firm
if you-
your theory. That's true. Go ahead.
Yeah, if you don't put the load on it, it'll hit over unity in the coil immediately, and then it's runaway. And you can't control it. So your load is to pull it in and out of the resonance state. That's where you need to go. And by the amount that you put on the load, the amount that the resonance hit. So you just got to think of frequencies like an AM radio. If it's not within the bandwidth, okay, it's not going to resonate. But once it's in the bandwidth, you start it. Then as soon as it gets towards the center, boom, that's going to just hit a state that's uncontrollable. That's why our transformers on our poles do not resonate with our motors, because they would hit that over unity state quickly. That's why they keep them off on the frequencies when they build them.
Mhm.
Yep.
So,
Yep.
Where you were talking about the garage and the temperature and all being a kind of a factor,
yeah, oh yeah.
then I'm feeling that perhaps we need to get barometric pressure sensors and temperature sensors alongside the Graviflyer when we start it up, and get a little Raspberry Pi Zero or some Arduinos and run some data collection on the barometric pressure when we're turning shit on, because that's the same thing as the air pressure and the water pressure in the drain giving us the vortex.
Mm-hmm.
Yeah.
Ever since my ears popped, I've been using this. It's old school barometric pressure meter.
Okay.
A drain cap.
Nice.
Yeah, it works, right?
Mhm.
So I can tell when I'm too high of a level of pressure in my room.
Now there's a bit of a phenomena that like I would like to kind of explore a little bit more regarding like Tauruses and stuff, going back to the drain, you know, because you know, like this represents like half of, you know, a Taurus, you know, and then it's got you know that the other way.
Yeah.
So the same as it'll drain out easier when it's coming in, it drains out easier. But the thing is that once it spreads again, it creates, you know, goes from a high pressure output to a low pressure dispersion, and creates then other toroidal shapes coming back at it from the bottom. Again, I'm not talking about energy flow, but I always find that these things tend to be analogous, and that's just something I haven't ever observed, you know.
It depends how much pressure you're putting in. If you are trying to go subtle on a cone, then you might get to where it's coming out the back. But generally, from my experience and from what I've learned and read, when you're putting pressure in a cone seed, sound pressure, it's going to force it all down to that compression point, send it out as a beam.
Send it out as a beam.
It will form a toroid at the end of the beam where it breaks its field and comes back in, but it's going to send it out as a beam to begin with. Because the
Well, you know, another
not,
train of thought though, if it's rolling sides, like if it's rolling like this, and then
it's rolling in,
it rolls so fast at the center. Now it's rolling around the center, right? But now when it starts to, well, usually if you're thinking about gravity being in play in just an object, you're talking about something that's going to destabilize after that center roll and fall. But if you're talking about something not subject to gravity because it's part of gravity, like, you know, energy, you know, it could be rolling, and then when it hits that center point, you know, it could just roll itself out to the next center then.
I get what you're saying.
But probably in a, you know, I don't know.
but compression goes forward in this situation. So because it's compressing and it's moving forward, it's making a congruent beam up the end, kind of like grabbing a balloon that's full of water and you grab the end of it, it just pops out the end, except it's a solid line. Maybe I'm wrong. That's just.
Can I segue on that?
Please do.
Straight dope. When you brought up the cone, I was reminded of something I had thought of years ago. My grandmother had a bag that was a cone, and she would frost cake with it. And she had different tips she would put on to get different flowers and rosettes and circles. And I was wondering, just a hole would be like a tea kettle. You'd get a single frequency whistle, but what would happen if you cut grooves into the tip of your cone for the discharge? What would the plasmons form then?
Okay. Hey, guys, real quick before you answer that, Sean's got to go. And I want to say thank you for presenting today, Sean.
It was my pleasure. Thank you.
Sean. Thank you.
Well, that coil was throwing the goods, my man.
Thank you so much. I'm honored. You guys are inspiration. Appreciate it.
You're awesome,
John.
Sean. I apologize if we kind of took over. We get carried away. You gotta throw in there. You know what I mean?
No, I was enjoying it too much. So
Oh, I understand.
thanks. All right. Take care, guys.
Right on. Thank you,
Talk
Sean.
soon.
Take care,
Bye.
Sean.
Take care, Sean.
Okay, Victor, you were talking about the tips going on, I believe, for pastry and doing different rosettes. And then I think Gerald was answering or somebody was answering.
I was going to answer or give you a thought. If you were to say come down a tube, like you said, like the cone, and then it came to a tube, and you were to make, say, like a U, so split the tube like 2 points, so there's a U at the end, you're going to find two balls of, I don't know what you call it, spark gap, whatever, spheres that sit on those two tips, those 2 points. You have charge separation between two.
There's actually a guy that made something, a cold plasma pen or something to that effect, where it actually did narrow a plasma stream down to a cold tip, which I forget what he did with it other than show it. But it was definitely directed, and it definitely had like a controllable termination point, which I found interesting. It was really, really stable. Like, it wasn't trying to do anything crazy.
Victor's got me thinking I want rosette points and stuff now.
This is about the dimensionality of these energies. That's, it's a great thought.
Go ahead, Victor.
I saw some research on cold plasmas where they were using that tip, and they actually use it for dental cleaning for people. And apparently a cut can be hit with this light and energy, and it increases the healing real quick. It's almost like you could slow a guy back up with that cold plasma.
I can't talk about that subject. I promised I wouldn't.
Okay, yeah, well, that is something to look into. Cold plasmas in health areas.
Yeah, like I said, I can't talk about that subject. We want to do a show
Magic
on that
it's
subject,
magic.
right? Completely on it. I got books of data from like Egyptian pyramidal experiments that need to be discussed. And
Well, Ben's got a website that says we can chat in it if we want. If we want to just do something off of this altogether, that's probably the way to go.
Oh, Ben's going to regret the minute you told us about that.
I got stories I can tell you on that subject that blow your mind. I got affidavits of people, but I can't talk about it. So, if you know what I mean.
Oh, man.
Yeah. I mean,
that's going to be one to record, that's for sure.
I'm going to put the link in the chat. It's basically a forum like Facebook, only it's not like going to censor you if you upload something. We could tag each other, and it's a better way to organize our experiments, I think.
Yeah, I hear you.
Device I was working on a little while ago uses piezoelectrics in water, and I'll leave it at that.
I missed that.
Piezoelectrics in water.
You know,
I'll leave it at that.
I was talking to Brandon, and he was telling me, you know, and it's something I had experienced too at a couple points in my life. But there's like a, you know, if you're ever in like a river that's very, very quartz heavy and stuff, you have the water flow over the quartz, and you could sense the charge off of it. Like, I mean, it's like an apparent thing. Sometimes, like as crazy as it is, if it's really, really rushing, even if there's no like storm, electrical storm or anything, you could smell ozone, which is very unique. Think about the implications of that. You know, if you're smelling ozone by a fresh water source that's filled with quartz, I mean, you know, realistically, just because it's underwater doesn't mean that it couldn't be creating, you know.
Okay, put it to you this way. I've done similar stuff with a device I have. I'm not going to get into details, but put it to you this way. When I took a sip of the water, I could feel electric charge on my tongue. Like, you know, when you put a 9-volt battery up on your tongue, that's how the water was.
It's interesting.
Yep.
Yeah.
We'll have to do it on that Fringe show offline.
Yeah.
Well,
I
you're
can't-
talking about the fringe stuff. There was a guy in the chat the other day who has a channel, and I was kind of giving him some props because it's a really good show. It's called Library of the Untold. That's the name of his channel. But, you know, I don't want to say he's a friend of mine because, I mean, I've really only talked to him a couple times. Really, I'm just a fan. But he actually wrote a book, and I'll put it up because he just released it, and I'm a few chapters in, but I'm already getting the gist of where it's going, having watched his material before. The book is called Book of Wonderful Suffering. And just to give you an idea of like some of this stuff, because it's like it shows how much it all ties in. On the back of the book, it says esoteric teachings, hermetic law, alchemical transmutation, Gnostic thinking, mythological allegory, physics and psychology, religious origins, Freemasonry, Zen, technology, biology, evolution, creation, ancient civilization, origins of language and art, abduction agenda from the Greys, Saturn, and the black cube symbology, and it says hallucinations, meditations, and kundalini. That's the contents of this book, is all those subjects woven together. So it's, you know, like it really runs the gamut as far as like all these things are concerned, because in fact, a lot of the trains of thought that I have all come from all these sorts of teachings rather than just a more traditional sense. Yeah.
I like how he ends with Kundalini.
Listen, I had the Kundalini come upon me one time, and let me tell you something. I don't know that I was ready for it. I don't know that I was ready for it when it came, but yeah.
What is
but
that?
Kundalini, I don't know. I'm not into that because to me, in a way, it negates God. Is it not?
I'm gonna give you my very honest opinion. No, it's very aligned with godliness.
Godliness.
Is it? I'm not familiar with
I'll stay away from that subject.
It's fair.
It's all good.
Well,
man.
actually, another way to think of Kundalini, if you want to think about it any sort of way, it's they call it the Christ consciousness, and from a Christian perspective, the only thing that the teachings are really trying to provide is to be more Christ-like, and to do what would Jesus do, right? And that's realistically what the Kundalini represents.
But the Kundalini is an Eastern philosophy, like it's from an Eastern religion. It's not.
Well, no, it's a biological phenomenon. I mean, they accept it as part of their.
I know what you're saying, and I agree with you 100% on the mechanism of the Kundalini. I don't believe in the terminology of the Kundalini because it refers to the Eastern philosophy on how you are self and you couldn't awaken your chakras, and you are the one that that can evolve yourself to a better state of man. You can't. You can work on your consciousness. You can work on yourself. You can become a better person to other people. But in order to evolve to a higher state, it requires a little bit more just meditation, in my mind.
Yeah, no,
Maybe I'm wrong.
listen, I don't know that I disagree with that, but it definitely takes more than just meditation. You know what it actually takes is it takes realizing the stuff and then practicing it to perfection, which frankly, between me and you, the practice to perfection part's being the difficult. But
Because nobody wants to look at themselves. You
Yeah.
got to look at yourself in an honest manner. Like I look at myself as when I was a child, I made a lot of bad decisions. Heck, I was an asshole. You know what I mean? Just to put it plainly, right? And you got to look at yourself in that plain manner. Otherwise, you can't change. You can't better yourself. You can't. How do you see what you've done wrong, or how do you see how to change yourself if you're not looking at what you've done wrong? Right?
well,
And
I actually give him credit where credit's due, because that's why the name of the book is the Book of Wonderful Suffering, because all the hardship, all the wrong, all the bad things that you've ever done, what makes it wonderful is the experience, the knowledge, the wisdom that the few gain out of it. The few. That's the thing. Many people don't.
true.
But yeah, Ben asked, well, what's Kundalini? So Kundalini is, and it goes by a lot of different names, but generally known as Kundalini anyway. It's a process that anybody pretty much in a certain state of being can undergo. That, first of all, it could be, it could be like spontaneous, okay? And you don't have to necessarily be in a certain mindset, like certain resonances and things like that. If you're exposed to it strong enough for long enough and whatnot, could actually induce you into a state of Kundalini, but a lot of times people that achieve it through like meditative states and reaching higher vibrations through meditation and through conscious thinking and things of that nature. And when you ultimately reach the point where it happens, I mean, there's a lot of different, like there's some science behind it, but it's a little disputed, although that seems to be pretty consistent. There seems to be a process that goes on that has to do with your spinal cord. Okay. Some say that there's oil excretion from, your pineal gland area, like that area of your brain that goes down your spinal column, hits the bottom, comes back up. And then when it comes back up, it basically gives you
and I get
transformative
yeah.
type of experience. Okay.
It's a temporary experience. It's a moment in time.
Well, that depends on, I'm going to disagree with you there. I'm going to disagree with you.
Okay. Well, if you've had the Kundalini and it's lasted for your whole life, then awesome for you. You know what I mean?
Well, no. Here's why I disagree with you.
Okay.
It's not that, and it's not that you're wrong. It's just depending. It's just depending.
A form of enlightenment?
Yeah, I mean, it kind of, all right. So when this happened to me, first of all, I wasn't trying to induce it or anything like that. I was just meditating and it happened. And then when I came out of the meditation, it was still going on, so, for me, it was kind of strange because it put me in a lot of pain, like a lot of pain. Like it felt absolutely incredible at first. And then, which usually isn't the case. I don't really get body sensations or anything usually if I'm in a meditative state. This time I did, and it put me in a lot of pain. And it put me in pain for days, and it was like crippling pain all up my back. And first it was my low back, then it was my mid back, and it was just burning and burning and burning. And like, it was so painful, and I couldn't shake it.
I've studied the Kundalini. I studied actually almost every religion there is because I wanted to know the truth. And when it comes to the Kundalini and the process behind it, in that belief system, if you are feeling pain while you're enduring the Kundalini, it's because you have blockages. Blockages you haven't.
That's exactly what it is.
Emotional scarring, traumatic situations that you never looked at, and to me, in what I believe, because I believe in Jesus Christ and that there's a Holy Spirit involved, I've been directed my whole life on how to deal with those issues that came from my past, that stopped me from moving forward. And that, in a sense, is like a life view Kundalini. I don't know if I'm explaining that right.
No, you're not. You're not. I understand exactly what you're saying, and I don't disagree. I mean, because I mean, I'm spiritual, but I also have my beliefs. You know, I don't like to say religious because that kind of sounds more denominational than I
don't believe in religion. I don't believe in religion. So, there's a big difference.
I mean, you know.
Yeah.
All right, guys, real quick. I just want to jump in here. Okay. The Egyptians balanced a feather of truth against your heart. So, just understand this. When Jesus was brought to the cross, he forgave the people who were going to put him on it. Okay? You have to have forgiveness and peace within and within your situation in order to achieve it. So, anytime you bring hate into a situation that has religion, you're wrong.
Yep.
You're just absolutely wrong. You went against what Jesus told you when he went to the cross. You brought it in the wrong place. You're wrong. Your religion's wrong. You better fix it.
Yeah, you're using it for your own means.
That's why I said I don't believe in religion. I believe in the truth that he spoke.
Well, here's the thing that a lot of people don't realize, though. So, by the way, what you just said, that's how I feel in my heart, and that's how I try to act. Okay, and generally, that was always a part of me. You know, generally it was, but you know, what they just said about, you know, in Egypt weighing a feather against your heart, really that runs very analogous with the Jesus thing, because see, you in that term, okay, you go to each god, okay, and that god asks you a certain question in your life. Did you ever, you know, and you know, you have to answer no, you know, and that's whether or not you did, because the question is whether or not you've forgiven yourself for that you've overcome that obstacle. It wasn't really about whether or not you ever did what they're asking. It's just about, in this crossing over, is this something you're taking with you?
Right. So if there's something that burns on your mind all the time that you did wrong, then that'll go against the feather. So you have to correct it. That's
exactly.
it.
Exactly.
You have to correct yourself. And then things start to happen around you when you do. Like, do you walk into say a 7-Eleven or an AM/PM or whatever you guys have around you, okay? And there's somebody outside that asks you for money, but you only have that $1 for that soda. Do you give it to them, or do you get your soda?
I give it to them.
You have to give it to them. And it's not because you have to, it's because it's the right thing to do. And no matter if that's a soda pop you wanted all week, no matter what it is, the right thing is the right thing, and that's the way you have to live your life.
That's right. If you ask you for $1, give him 5.
That's right.
Or give him
don't ask him what he's doing with it.
Yep.
Don't judge him. Yeah.
Exactly.
It's in your heart. It's who you are. That's it. That's what you gotta live by.
People that ask you for change, they're your brothers and sisters. They're just down and out. They're no different than you. You're a heartbeat away from sitting on that same spot that they are. So if they ask, you give. That's the way I feel. I don't know. I wish that everybody would feel that way personally. But
it doesn't just change everybody around you, it changes you. That's the important part. You see things differently. Yeah. Things are opened up to you. You're able to evolve who you are. That's
so. I want to interject in this with the relevance to the Kundalini, because there is one, and this is the change in perspective, which becomes very interesting. Okay, and this is for Ben, since you never really heard of it. Okay, so when you reach the point where it burns through you, okay, and hopefully, if if you're in alignment enough, hopefully it doesn't do it too bad. You know, you get to this point where, like, I really can't describe it, but things just all of a sudden make a lot more sense. Okay. And when things start to make a lot more sense, you could see things much more clearly that might have been in the haze before. So, like, you know, you become more empathetic, you know, and you are able to pick up on other people's situations more easily. And then you feel compelled to, you know, do exactly what Nathan's saying without being asked. And that's sort of the beauty of it, is it unfogs you and makes things in a much more clear picture that allows you to then know your place in any given situation and judge it out just a little bit better. Now, you could actually have this happen more than one time. And when after you've overcome the first time, now you could do what Gerald was saying earlier. Well, that's just a one-time thing. You get it, and that's what it is.
Okay,
or
that
you
was my
could,
next
or you
question.
could, right, or you could realize the significance of what that's brought you.
So
You
it's
know,
something that
and
you
then
go in and out of. It's hard to maintain for a long period of time.
See, and what you're talking about is what Christ gives to Christians. The same
But, like,
thing, the awareness, the awakening, all of it. That's when the Holy Spirit comes upon you, that's how it is. And it's like that for the rest of your life. You can't get away from you even if you want.
now,
So,
for
like,
me, Christ was directly related to my Kundalini experience, you know? So it's however it comes to you,
right.
you know?
I ain't judging you. I'm just
No, I'm saying it is definitely however it comes to you. But no, first of all, the feeling of it or whatever, this is on, once you have, it's like any experience. It is what you do with it. So if you had it and you're like, yeah, that's good, and you think about it like some kind of drug or something, then, you know, at that point, you're going to come off of it and be like, well, that was cool, whatever, you know. But if you realize the significance of it when you're going through with it, you don't want to live any other way, you know. And, you know, if you've been doing work on yourself as it is that helped induce it in the first place, like, you know, it'll blow your ego into smithereens and just say, you're absolutely useless to me, and now you're going to be whatever I decide you are, not whatever you've become. You know, it like really is that significant if you go through it, and if you go through it and perceive it the right way. If you don't, then you don't, you know, like, but to each his own, I suppose. I actually had a friend that went through it, and he went the complete opposite direction with it. He just, however he was before, he just became a worse version of that. And he can't snap, and he legitimately cannot snap out of it. And it's been years.
it's his ego.
Yeah, it's absolutely his ego. And I called him out on it 100 times because I care about him, but I did it in a very, like, hey, you know,
That's
I
why
just want to tell you, you know, right, in a constructive way, not to put him down, you know, just like, hey, you know, there's
That's
stuff that I'm seeing that might help you out if you see it, but if you don't,
that's where
hey,
humility comes in, but it's hard.
Yeah, just so we can get this kind of back to what
Yeah,
we
I'm
talked
sorry,
about
we're
on here.
going off here. We got to get back to
it went off the rail, but I said it was.
No. But let me just say this: if you have a clear mind, then you can work on all your circuits for the day. I cannot build a circuit with a mind that is not clear. I blow
Not wrong.
everything up. I walk away. I realize it's happening, and I stop. And I say, "This is not the day for me to work on this. I need
That's
to walk
why-
away."
That's why I had to bow my head in shame at the beginning of the show. I had one of those days yesterday, man. It was bad.
I had one where some unfortunate MOSFETs decided to blow up in a row, probably about 20 of them. And I just said, it's not my day. This is just not my day. And it's
Yeah.
the simplest circuit in the world. And all I
Before
was
we
doing,
get off of this, though,
my
Nathan,
iron was too hot. That was it.
Yeah.
It just
Before we get
heated
off
up
of this,
too much and
Victor,
blew
I
up.
cut Victor off, and I feel terrible. So,
Yeah.
Victor,
Go ahead, Victor, whatever you got.
it was like a mile ago when he was like Kundalini. I was like, oh yeah.
Well, I thought it was interesting he ended with that. And a thought came to my mind that with anything, don't approach it with fear. even though the book's title uses the word suffering, if you look at the etymology of the word, suffering does not mean pain. It just means to undergo change.
All right.
So don't approach it with fear. Because
Is
that's
that-
the emotion that leads to everything else, anger and
Right.
I guess
That's what's left at the bottom of the well. After the Kundalini, you realize there's only two things in this world, and it's love and fear. That's it. That's what's at the bottom of the well. You know, because everything is a derivative of one or the other, and fear is opposite of love. Everything that you fear is in some way, shape, or form just, you know, you being concerned about not being loved in some way or being hurt in some way because someone doesn't, you know, like that's what it all boils down to. Really, it's just love and not love.
And the etymology of the word suffering going back to mean change, you know, like that also plays on that scientific analysis of, you know, people are at their most effective and most efficient when they're slightly uncomfortable. You know, they have that. You can't be 100% comfortable. You have to have that slight uncomfortable, because change is uncomfortable. You know, it's not anything that you should fear, like Victor said.
Change is light.
Yep.
I love change. I love life, though. So
Yeah, that caterpillar turning into the butterfly, that's probably a lot of, you know, suffering, but you know, it's worth it. You can fly at the end.
Yep. It's like Maynard said, embrace the random. You know, and whatever will bewilder me. So, yeah.
So you guys were talking earlier about the vortex and the cones and stuff. That wasn't in the discussion. So basically, as you create that point of that it condenses into, okay, and it does it because you're creating a magnetic field in there, and you get a high Tesla level, so it pulls it in. This is what people don't realize about their coils. They're pushing out as well. So the outside of the coil pushes out, the inside pushes in. Okay, that's the toroid structure right there. That's how it works. Now, you also, because it's not straight, it is bent on the bottom like this when he does his coil, because he zip ties them. So he's getting a curve. So it tells it where to start the angle to go like this, right? And then as that's going, then the pressure from that point right there in the center as it's coming in will start to turn it, okay? Because magnetic fields, when they come into contact with voltage, they spin, and they spin in that magnetic field. So you're going to get an equal and opposite field on both sides. So your cones will go into each other just like that. It's a natural progression of the energy if you follow the flow.
Yeah, and you know that in my mind, that's how that went. But then it just didn't add up with in that particular case with like the analog version of itself, you know, like, and that's where it was like crazy, because I know that it spins opposite. You know, that's where the torque and the force comes from out of it. So it's super interesting, man. I don't know. I just wonder what, you know, I sent you a video. I don't know if you watched it yet, but there was a thing on cones, and it was talking about how cones are used in speakers to project the sound and amplify the sound. And well, that makes sense, because if you go into the end of a horn, you go, oh, you know, it comes out louder out the other side.
Mm-hmm.
But, you know, what's kind of interesting is, like, you know, if you think about it, realistically, you have more pressure coming out of this side. You know, so what they were saying is, like, if you play, you know, a speaker in a closed system, you know, with a cone at the end the other way, that you get the acoustic version of scalar that comes out the end of here. And it's so, yeah, that's what it's called. Exactly. And
What was it
they were
called?
saying that that's where the magic's at. I was like, really? Okay, need to think more about this, you know?
Well, yeah, because you're creating like a, when you're talking about a speaker, you're creating a movable magnetic field is what you're doing. So it's going to pick up resonances. So you're picking up frequencies along the way. So that's what it does. So it makes all the sense in the world when you got two things like a Tesla coil. You're going to make like a speaker basically. Now it doesn't to have a diaphragm on it to give you the high sound and stuff like that, but it's going to do the same thing. I mean, you just have two magnets running against each other. That's all it is, and they do it in one frequency, not all of them. So you're not going to get this beautiful sound out of it. Not unless you look at the
Victor,
whole
what do you know about that subject? I'm just curious because they kind of glossed over it.
About which subject?
Oh,
I watched
about
when I
the
was a kid, and I was a fan of Doctor Who, so I had to stay up because it was on late and I had a little black and white TV. Well, one night after Doctor Who, there was a public broadcast show about the power of light and sound. And of course, they show the sound trumpets moving the walls like Jericho, right? They show how that works. Well, the one that fascinated me was, the Asian hats that are a little cone. It's not a sharp cone. It's kind of spread out. There were these quartz crystals that polished different cone angles into. And it was on this big ultrasonic transducer. And they were using, I guess, plastic fiber or carbon fiber. And they were showing how the ultrasound would focus exactly 1/8 inch above the tip of the coin and make a miniature ball of heat, a star. And they were melting the framework of where the fibers all came together to make solid bonds in this craft or car or whatever it was. I looked at it and said, oh my God, I got to have one. I am going to build a ship out of Legos, and I'm going to weld my Legos, and I'm going to cruise. And another thing that came to my mind was, what if I could take that same crystal shape, put it in a singing bowl, and boil my water and cook my rice? And I know it's ultrasonic and the bowl is subsonic, but I thought, hey, there's something there. And when you were talking, I just realized the Sazer is vibrating the crystal form to liberate the electrons to a focal point, and that's what made the little star.
yeah.
Well, when they talk about the walls of Jericho, just so you know, the Ark of the Covenant has to be a frequency generator. There's no way around it. It has to be.
High voltage.
Yeah. So
part capacitor, part oscillator. Yeah.
Yep.
Yeah. It just, when you walk around it, what did he do? 11 times? I think it was 10 times for 10 days or whatever it was.
7
days.
On the last time they blew the trumpets.
Because you have to start resonating everything at the right frequency, and then sound is movement. So sound moves things. So that's why it fell down.
Yeah, I think they used constructive interference till they got to the last, and then they used destructive interference.
That's right.
Down. Yeah.
That would explain precision cutting.
Yep.
Yeah.
I'd say.
But EDM?
Vibration to energy. Tesla all over again. It produces a frequency. You just need the right substance to channel the vacuum modifications.
Okay, so if you use an EDM in Egypt, by the way, the only thing you have to do is activate the quartz in the granite. And then you have something that's electrically conductive that you can cut it with it. So just so you're aware that everybody probably here can make a quartz electrically conductive. So it's not really that difficult. Then you cut it with the EDM machine. And that's how you get precise lines. And it looks precisely the same as what you see in Egypt.
I use a water jet at work, and the garnet that we put in the machine, the sand, it's got silicon inside. It's actually very sharp. So you put that and you put that behind a pump that puts out 60,000 psi. You have the sharpest knife on the planet.
Yeah. No, they are.
Yeah.
I can cut through 4 inches of solid stainless steel with my machine.
Nice.
Yeah,
Or
garnet's hard stuff. You know, like that kind of pressure, forget it.
Yeah, 60,000 psi. Yeah, you could cut through a Buick.
Yeah, but you can't exactly get, how do I say this? Depth. Your depth has to cut all the way through, right?
Yeah, like my machine is limited to 4 inches.
No, but I mean,
So,
no matter what, you have to cut all the way through the piece of material. You can't stop in halfway through it and cut a cavern out of it.
No.
That would be the difference in EDM. You cut distances.
Yeah.
So
It has its limitations, but for cutting, say, like granite or quartz,
it works
or
beautifully.
anything,
Yeah.
it's amazing.
Yes, it is.
Yeah.
Especially if you get into cylinders and stuff like that, harder shapes to cut. If you can get it in the right angle, it's perfect.
Well, I've worked on the Omax A-Jet, and it could actually cut at a 60-degree angle. So you can do angle cutting to make it more three-dimensional. Obviously, that has its limitations as well. But for what it is, it's pretty amazing.
Yeah, I agree with you. 100%.
I know nothing about it, man. I'm just kidding.
All right, one more mind-bending subject. What do you think about Kazarev mirrors, Victor?
I
Do
actually,
you know about that?
yes, I just watched his. Oh man, that must have been a month ago. I liked the back of the spiral. I was wondering how it would shield, or if it funnels. But as I understand, and over here in the chat, people are saying that shields against fierce EM and magnetic field. That would be interesting. I was wondering if he,
my understanding was that it acts as both a shield but also a vortex simultaneously.
so it does accumulate and puts you in the center of it.
Yeah, because I mean the whole thing is you know, is a spiral, and it's you know, to the golden ratio, and it's aluminum and it's polished. So that's really all it has to be. I mean, I understand that the taller the walls, the better it works. That's what I've understood of it. But you know, I think that the effect was that it blocks out the EMF.
Right.
But what that creates a vacuum, which ultimately then starts to vortex it because of the vacuum that it causes. And apparently they supposedly work better the further north you are.
And what's that exactly?
That would work.
Yeah, right. Okay, so what it is it's imagine building out of like sheet aluminum, okay? A spiral that follows the golden ratio, okay?
Yeah.
And it spirals at least one time around itself. So it's something that is big enough where you would have to, you know, you'd walk into it.
Okay.
Okay. And in the center, you put a chair. That's the entire thing.
That's it?
It, supposedly, if the mirror is polished on the inside, you know, that amplifies the effect. So the theory behind it, I guess, is it's multifaceted, I suppose. The first theory behind it is that it blocks out a lot of the EMF, okay, and
okay.
then
I see where
it
it's going.
vortexes the EMF in the area.
Yeah.
When you're dead in the center of the thing, it distorts space and time and makes the time kind of stack and makes it accessible.
You can do that with sacred geometry and coils. The bigger the coil, the bigger the space that you can do that with. But ultimately,
Didn't you say you're building us a Stargate, Gerald, when we all show up?
Working on it. 12 feet in diameter.
Wow.
So supposedly there was a test that was done back in like the 80s where they had built a whole bunch of these coils in like arrays almost, because like, you know, they would have a warehouse and they would just be filled with these coils, and they would have different warehouses throughout, you know, Siberia and stuff, and they would have test subjects go in to these you know, mirrors at the same time. And what they would do is they would literally have one person, you know, looking at a picture. Okay. And then I think they had like 95 or something other people. And they asked the people just to sit there and whatever thought randomly came to mind to draw it on a piece of paper. And it had like astounding accuracy to the point where it was like undisputable. It was like, you know, the person was looking at a card of a triangle, people drew a triangle. People looking at an X, all of a sudden everyone felt compelled to draw an X, a banana, a tent, whatever it was, you know, and it was just time after time, person after person coming up with the correct thing in the correct sequence, like beyond mistakable, you know. And
I imagine that the aluminum was forcing a vortex to occur, a form of shield for electrostatics. I've proved that in multiple videos. So
Focusing. Yeah.
it's a vortex, a scalar vortex affects the spiritual, or as some would say, your conscious. How much? I don't know. I've never done experiments, and it's something that needs to be looked at extensively. But for the time being, I don't see it doing like what I work with. I can't see it extending that sort of a psychic ability or that sort of connection. But what you're talking about, those specific aluminum coil systems would have been grounded, because as big as they are, they have to sit on the ground. So I imagine that there was some form of a connection through, as that vortex is coming down and they're sitting in the center, it's grounded out, they're grounded out, and they're connected to that ground.
They're built on wooden platforms.
What's
They're built
that?
on wooden platforms,
Really?
so they can be moved in the building. I'm thinking that because it's tall.
Yeah.
Fractal Woman that just did interview with a guy that has the new theory of electricity. He believes that at every millimeter, as you go up in altitude, time is different.
Yep.
So
I
this thing
believe that.
being tall is accessing time. Anytime you have a conductor, it's just a straight piece of wire, you're conducting the electric plane. But as soon as you loop that wire, you're closing the flux. And now you're conducting the magnetic plane. So I would think that Kozyrev mirror is focusing the magnetic energy into something to where whatever's inside is magnifying its toroidal field, and anybody in the field is then receiving the transmitter that's getting the magnetic flux, because his amplitude is overpowering the local near field. If that came out right, wherever that came from.
That's
now
an
here's where it gets a
concept.
little woo. So one of the first guys that they put inside this mirror, first of all, before I even go there, every single person that's ever been in the vicinity of these things, okay, has supposedly said that there's like an ominous feel of dread for some reason anytime they're in the area, which, you know, given my angry rock, I could understand how those types of effects could be like, you know.
Well, they get locked into the environment. So
well, right. I mean, whatever equilibrium you're at, it's messing with that equilibrium, because when you go inside, you also get sick.
Right. Sometimes people that are sensitive can sense the ELF frequencies of a break in the crust just before an earthquake.
Yep.
So maybe the sense of dread is the fact that this thing is funneling magnetic flux into the ground, and it's not a pump, it's almost a hole. And so anytime you're near a hole, you're going to dread falling. Perhaps the sense is there because of the flux.
Exactly. Then that's what I was thinking too. And they would have physical effect from it, like vertigo and stuff like that. Nonetheless, without going in there, the first guy that ever went in said that he was feeling sick, and then all of a sudden he didn't. And when he didn't, you know, he saw the reflection in the mirror, and he walked toward the reflection in the mirror, and it wasn't a mirror anymore. It was just like he was somewhere else. So he said that he found it fascinating because he had like deja vu about it. Like he recognized the place, but he didn't know where he was. And he said that there was a kid walking, and he naturally walks faster than the kid does. And, you know, he said that he walked past the kid and looked back at him and realized it was himself in his old neighborhood. That's now, again, woo. You know what I mean? Like, I mean, how much of it do you want to buy? But at the end of the day, like, whatever's going on in there, it's kind of a strange story, you know.
Well, there's lots of woo stories out there that could.
There's a lot of woo stories out there.
Yeah, go along with that. So, what were we gonna say, Victor? Sorry.
if time does change with every millimeter in altitude and that thing's funneling, that then maybe it's a time vortex. The flux is affecting time. Because if if the Vajra can do it, the Vajra motor,
Yeah.
can change time, then that thing is focusing it perhaps with a fine angle.
And if the focus of that vortex had nothing to do with the location, but rather the locality of the individual, it could very well make sense as to why he saw the back of himself.
Wow.
I just wonder how you can affect time without a bubble. Like, could the vortex itself just do it? Or would a bubble have to form for that person to have those effects?
Well, I mean, if the thing is acting as a vortex, the vortex itself is the bubble, because a vortex by nature of itself is just that. It's self-contained within itself.
I wonder if it goes along with what Victor had just said. Because our hearts, when it's beating, actually creates a magnetic toroid. I wonder if that machine is amplifying that which the person's putting out.
I think so.
So if they're
Could well be.
yeah, so if they're like thinking about the past, they're experiencing their past because it's amplifying their consciousness to that time. I don't know. That's interesting.
Yeah.
Interesting.
Lots of different possibilities there, but whether it's paranormal physics or whether
I think,
it's
what, all paranormal physics is like misunderstood high voltage and grounding, as far as I'm aware. Like a ghost, for instance, right? A ghost is like a snapshot in time of where two polar opposites have met. A plasma has been created in that spot. Memory, through the emotion of what that person went through, locked into that plasma, and that moment in time replays every time the earth shifts in such a way where it creates that condition again.
I don't disagree with that at all. I think that's spot on, man. It's anytime there's like a big energy discharge from somebody, it's basically like exposing, a piece of film, because it's just there. And again, right, if it's in the same conditions.
Yeah, it goes with what Victor just explained about that machine. It's all the same thing. Your consciousness, where that emotion, that moment attaches to that plasmatic form, and it repeats like you just said. So it makes me wonder if, because our hearts create a plasma toroid we don't see, that machine amplifies it for people. It's kind of like they're living their own ghost kind of thing. You know what I mean? I don't know. Maybe I'm saying that wrong.
So I don't know how woo we want to take this, but I'm going to tell you a story very quick, that I think everybody will enjoy, because it's a good story. All right.
It's got to lead back to science. Go ahead.
You know what? It's scientific because it just goes to show how far these things can go, and whether you believe it or not, I promise you, if nothing else, I'm telling you the absolute truth. Okay.
Yeah.
So I used to restore straight razors. I had mentioned that a couple of times. But I was at an antique fair one day, and I actually saw a safety razor, and I was like, you know what? It's a couple bucks. I'm going to buy it. And it was in a box. The original box came in whatever. Okay. So I brought it home. I don't really use these things, so I just kind of threw it to the side. And then one day, okay, I just, for no good reason, I had like this urge to just clean it up. And I was going to like stop what I was doing to clean this thing up. I just was thinking about it. So I went and I grabbed it. I went to go clean this thing off, and figuring I had to restore it. I had all my tools out, and I realized this thing doesn't even need restoration. It's actually in good shape. It just simply needs to be cleaned. So I go and I take it into the bathroom, and I get an old toothbrush, some soap, whatever, and I'm scrubbing away at the thing, and I get that feeling, like the mirror feeling that people described, where like I just felt like something wasn't right, but I ignored it. Then I felt like something was there, and I ignored it. And then I felt something grab me, and I turned and I looked, and nothing was there. And I was like, all right, whatever. Still ignored it. not scared at all, but like just kind of ominous feeling. Long and short, I felt something move behind me. And then windows closed, not a reason in the world. My door flung shut, hit me in the back. And I dropped the damn razor and ran downstairs. Now, this is where the story just gets worse and worse. I come downstairs, my ex-wife and my son, who's 18 months old at the time, they were downstairs. And as soon as I came down, I didn't even get one word out. And she goes, "Did you leave the door open or something? Because it just got really cold in here." And all the hairs stood up on my arms and her arms simultaneously. Okay. Then she goes, "Your nose is bleeding." I don't get bloody noses. She goes, "Your nose is bleeding." And then I look at my son and his nose was bleeding. I was freaking out at this point. I was like, okay, I literally came down here to tell you that I don't know what was going on, but like I was just cleaning off this razor and all of a sudden it was like, all these crazy things. So we're like, well, what do we do? We actually call her Jamaican, very, very Christian friend. And she's like, "Listen, you're going to tell this thing wherever it's from to go back to God, go back to heaven. It's dead, tell it that you didn't mean to bother it, that sort of thing." Okay, fine. I did that. I bagged up the friggin' razor. I brought it out to my garage. I'm like, now what do I do with this razor? Because now, mind you something, I'm like, if I cleaned it and I pissed something off, imagine what would happen if I just threw it in the garbage or buried it or something. So the only conclusion I could come to, all right, was to bring this razor back from where it came from at this antique fair, flea market. Okay. And fortunately, it's every Sunday. So even though I had bought it like a year prior, it was still on Sunday. So I go, I put the thing, get there, and it's in a plastic Ziploc bag. I put this razor, which is it's really, really heavy. It's like a piece of solid brass. I put it on a guardrail that's about 10 inches wide, while I get my son out of the car. I'm getting my son out of the car. About 10 feet away, I hear a sound, and the bag is next to me. I was like, man, this thing got to go. So I pick it up, go to the first table I saw. I'm like, "For sale." Just put it on the person's table. I was like, man, I don't need these jujus no more. I don't know how else to get rid of this thing, but I did. And honestly, after that, nothing else ever happened with that razor. But I don't want to believe it. I don't want to believe it, but it happened, and I was there. And what do you make of it? I wasn't even the only one that experienced it. It was,
I know about the woo, man. I know a lot about the woo. One of the reasons why I started looking for EBOs, ball lightning, exotic vacuum objects, I didn't even know what they were called until I bumped into Bob Grinier's channel and started watching the Martin Fleischmann Memorial Project. And what he was describing, and I'll go a little bit into the woo and then we'll get off the woo, okay? I had seen ball lightning when I was 14 years old, but it was connected to someone who did something in the house they shouldn't have done. They killed themselves, right? And I was with my girlfriend and her best friend, and I was at their place at 2 a.m. We were just hanging out, playing cards, and we decided to crash out. It was too late, so we're all laying down on the floor, nothing funky going on, people. And we're all falling asleep, and all of a sudden the room got really, really cold. And I popped my head up, and I could literally see my breath. And then I seen this blue sphere sitting above my girlfriend's best friend's face, just sitting there, just levitating. And I was like, what the? And I said it out loud, and it took off out the door and up the stairs. And the girl's name was Pam. She jumps up. She's like, "My brother." And she starts running up the stairs. So I start following her. So we get up to the 3rd floor, and she's like, I can't get the door open. I can't get the door open. I'm like, what's going on? So I go to try get the door open. I couldn't get it open. And I'm like, piss on this. I pushed her out of the way, and I kicked it open. And there's her little brother hanging out of their 3rd-story window with his hands like this. And he's saying, no, Dad. And Pam runs into the room, grabs him, and pulls him in, and closes the window, and he's crying, and then we all go downstairs. Well, the ball lightning that went up the stairs, I believe, because of everything I've read and researched and learned, that because of what he did in that home, that emotion was locked into that space. Whatever was going on in the atmosphere built up enough pressure to allow that energy to manifest and show itself. Now, what was going on with her little brother, I can't explain that. But the door being locked, him being out the window, I'm not sure about him being out the window, but the door being locked, magnetics, electrostatics. It just made sense scientifically for me. So I know about the woo.
Yep.
Yeah, but it's
that's it, man. That's a crazy story.
Yeah, I've lived some crazy things in my life.
Man, you guys got some crazy lives. I wish I had a ghost. I'd have a
Nathan?
buddy to talk to when I'm working.
Nathan,
I don't get
no
I don't get
idea.
UFOs. I don't get aliens. I don't get any bad jujus. I don't get nothing. They just
Nathan,
don't like
you have
me.
no idea. Wait until I come out with my channel. You're going to be like, oh my God, I had this guy on my show.
Yeah, well, I'd like him to visit me. Maybe that's the problem. I'd sit him down and have a conversation with him.
Man,
It's different.
Yeah. Well, you know what? First of all, when you're at a very neutral point, like in yourself and such, okay, you sense these things way more, you know, not to say that you're not, but there's always a state of neutrality that you're at where all of a sudden, like every little difference makes a difference, you know, and you start picking up on more subtle things. But, you know, there's, for whatever reason, and I guess some people are just more susceptible to it than others, like there's high energy points that just hit at certain points that it doesn't even matter where you're at. It's going to make itself apparent to you, you know, like I don't know.
I think it's totally cool.
Like an antenna.
And I'd love for it to happen. That's it.
I'm surprised it hasn't to you living in California. The fault lines in there's got to be spots that are just incredibly charged and electrified. So,
well, I'm sure there is.
My guess is there's got to be a lot of people that see some strange things out there. But again, it's a guess.
My understanding, though, is high voltage areas and places with a lot of ozone and stuff like that. It acts as a disruption, also to like that sort of energy. You know, like that. I've read that before, where they actually say that if there's like things going on or whatever, like they'll use a spark gap generator to generate ozone. You know, because it purifies the air, sure, but because it puts a charge in the air, and you know, just like anything else, that creates interference. So, you know, it might not ever get rid of whatever it is, but it could interfere with whatever it is. I don't know. I honestly don't like to, it was honestly something I don't even like to think about because it sounds crazy. But
I got
a woo woo story.
I got a woo woo story. It has to do with a cross, but you go ahead there, Mike.
Okay. Okay. So what happened was that day, I was going to work on the Renegade device, and I can't even remember what happened that day, but it put me in a really, really bad mood. Really bad mood. So I figure, okay, I'm going to do something that makes me happy. Naturally, I pull out the Renegade device, try to turn it on, and it wouldn't work. I'm going, wait a minute. It worked like, you know, yesterday. no problem. I haven't changed anything to the circuit. I haven't done anything modification, nothing to the circuit whatsoever. So as the night progressed, I was getting more and more frustrated, and I felt like the energy in the room was different. It wasn't the same like normal, probably because my mood wasn't in a good space. I wasn't in a good frame of mind. So I go, okay, what I'm going to do, I'm going to step back for about 5 minutes. I'm going to go and just kind of chill out. And during that time period, I decided, okay, I'm going to do a little prayer. I'm just going to try to clear my head, try to get the vibe good in my mind again. And lo and behold, after I did that prayer, I went back, I turned the device on, it worked like that. It came back on. Like
Yep.
somebody just flipped the switch.
Funny how that works. Huh?
But you know, it didn't happen just one time, it's happened multiple times where even if somebody came into the room and was in a very bad state of mind, you know, angry or whatever, or you know, frustrated or whatever, my device refuses to work. It shuts down. It'll be working for like 20 minutes straight, and say my wife was mad or something like that. Boom, my device will shut off.
Voltage
emotions
dependent.
cause inter-
Yeah.
I can't explain it. It seems like it's really weird. This is where the woo woo kind of comes in. It's almost like it's like an entity, because if I get the motor into resonant frequency and the motor is running excellent, it seems like almost like it has like a consciousness of itself. It's really, really odd. You have to experience it to understand what I'm saying. Maybe Gerald's maybe experienced the same thing. I have on a number of accounts where
There's
almost.
some, yeah.
Go ahead.
There's some woo I don't talk about.
Yeah. So also, too, I do notice if there is like a solar flare, my motor runs incredible. Like
Yeah.
if there's
I
a
get more
solar
power.
flare, yeah, I get way more power. I also get more power at nighttime than I do daytime.
Yeah.
I've never tested that theory, but I get more power out during the beginning of a thunderstorm than I do on.
Now, one other thing that's really interesting about my device, if I go to a higher elevation, my power output is greater.
Yep. Same here.
There's a couple reasons for that.
Yeah. Well, I've even John Bendini back in the day, he says, yeah, just go up a mountain and turn your device on and watch what happens.
What's your theory on that, Victor? For a couple of reasons for that, because of the atmospheric pressure.
No, so wouldn't it be lighter as you go up?
Nope. Actually, your voltage potential increases as you go higher. As long as your device, as long as your device is isolated from the ground, it is now in the potential of the elevation that you're at. So for every meter, it's approximately 120 volts, right? AC.
Wow, really?
So if you go up an elevation and your device is off the ground and isolated from the ground, that voltage potential is now can be in your coil.
Yeah.
You know, we talked about this last week when I was talking about you know, where Earth's atmosphere meets space, and I was describing it as, you know, an energy field meeting a matter field, and how it's diffused into a state of you know, flux and equilibrium, which is our magnetic field ultimately, but it's gradient, you know, so it would make sense that because of the gradient, that the further you get away from the atmospheric matter, the more energy like it becomes and the more potential. So I mean, that kind of makes sense.
Yeah. Here's another experiment I did. I made a pyramid out of bamboo, okay, approximately 2 feet by 2 feet by 2 feet. All right. Put it on the ground, I put a coil hanging from the top and a little extra wire off the top of the pyramid. Okay. Then the wire coming off the other end of the coil, I brought down and I put it on a pancake coil made of speaker wire, and I grounded that. Okay, or sorry, from there I put it to my hand, and then I put my other hand to ground, and I was able to achieve 25 volts AC.
Wow.
You were able to what? I'm sorry.
I got 25 volts AC.
Nice.
Just 2 feet off the ground.
Yeah.
Which
Yeah.
is part of the circuit.
So
That's
when
pretty
I saw the
sweet.
meter, yeah, I was totally flabbergasted seeing 25 volts AC. With a coil off the ground only by 2 feet. Now it's very important that the pyramid is a dielectric. Either bamboo, wood. They actually say some of the best material to use for it would be PVC. Copper is not a good material to use. A lot of people make the pyramids and they use copper. Wrong material. It's got to be dielectric.
John Keeley made a pyramid out of solid aluminum. It was a foot tall, and then it was cut off flat at the top, and then the apex, what's the name of the stone there? Basically completes the pyramid. That was, yeah, you could call it that. Yeah.
What is it? Herkimer quartz or?
No, actually, what was on top was a solid copper pyramid on top of the aluminum pyramid.
Oh, okay, yeah. I've seen that.
And he was, with Kirlian photography, he was able to take a picture of the scalar waves that were vortexing into the top part of the floor.
Yeah, it's very important that the pyramid is a dielectric. Very important.
Yep.
If you're using copper or something that's conductive, your results are not going to be as good. So, like PVC, plastic, even wood, you could use wood. I've done some experiments with it, totally 100% skeptical on it. To me, seeing is believing. I made it, now I'm a believer.
Well, the Russian Federation of Science wouldn't have spent a few $1 million on pyramid research if it was just hockeyism. You know what I mean? And they went to town. They built hundreds of pyramids in Russia in order to find out their purpose, what they were for. The anomalies seen were incredible. It's insane, the information that came out of that. It's not shared with it was shared with the rest of the world, but most of the rest of the world ignored it.
Well, they just look at it as fringe science, right? Automatically you say something and you have what's the word I'm looking for? A pre-notion that second you see something, you make a
premonition.
Like a biased,
biased opinion
about a biased opinion and
intuition.
Right away. It's more of a bias. You see it and it's like, no,
I missed what you were saying. Sorry.
Yeah.
I have a theory that the reason the pyramid is truncated is there's not just one capstone. Depending on what you want to use it for, the 5 platonic solids, I think the first, that it's actually truncated with a tetrahedron. And that one corner of the tetrahedron gets stuck in one corner or the other. Because in the zodiac, you have what are known as the triads. So you would have the 4 elements. So I think because in number theory, there's only 3 numbers known, even with supercomputers, there's only 3 numbers known to us that are both square and tetrahedral. The number 1, the number 2, and the number 140. Okay.
Interesting. So what you're saying? So what you think, or your theory is that the pyramid had more than one type of capstone for more than one purpose. That's fucking genius. Pardon my language. I never even thought of that.
Yeah, and that makes a lot of sense with the material differences too. If you want to think about potential energies as, in terms of like a light spectrum, if you want to think about it that way, if you're bringing in all the different, key components and then bringing it to a center point, it's like kind of making a like white energy. If that makes any sense.
It
Like the
does.
same, it's yeah. I don't know. It makes sense in my head.
Well, that number 140 is kind of key. You guys familiar with Leonard Susskind, the professor that deals with like time travel and the arrow of time, and he's done fractal flows and the arrow of time?
Yeah.
Well, in it, he discovered that in his first movie, he did the arrow of time. He showed this 11 vortices. They're like shedding vortices around an object, like the planet in space. Well, anyway, it has these 11 vortices, and he says that the arrow of time is such that these 11 vortices create a arrow of time, and the reason it's one way is because the pressure is 140 to 1 to be a back pressure. Okay? And that's the
Sounds about right.
You'd have to watch his deal. But when I saw it, I had to take my piece of paper and put it on the damn screen, trace this formula and the 11 patterns, right? It just so happens Nikola Tesla built something called the one-way valve, which has 11 side-to-side vortices, and the back pressure on that valve is 140 to 1, which is 2 of those square tetrahedral numbers.
Wow.
I know what valve you're talking about. It's awesome for, like, say, a flamethrower. Anyway,
if you want to know what it's for,
that's awesome.
140 to 1 back pressure is to have a system whose pressure can match the arrow of time, and you can drill through it.
That's you just blow my mind.
It does.
It's time spray at that point, It's
that guy was
spray.
Did an interview with a scientist that believes time changes at every millimeter. That's why the measurements 1 over e to the phi and the 1 over 3 phi, if you do they're 1 millimeter apart.
See, that makes sense to my experiment in a sense.
Or something. They're 1 millimeter. Anyway, think about that.
I'm not up on the whole quark thing or the muon, photon, theon. I don't really care about them. But I understand what you're saying in the sense where I've seen that. When it comes to time, one of the experiments I did, it actually took time to build it up.
We've been on for 3 hours and 16 minutes. That's the square root of 10. That's very close to pi, 316.
You're right.
Coincidence?
Actually, yeah, we're going to be, I guess, cutting it out soon. I wanted to show a waveform I wanted you guys to look at and get
go for it.
thoughts on.
Yeah, put it on up.
I got 2 waveforms I want you to see. This is the new coil. Oh, wait, I guess I should share it, eh? Let's see. I have it now. There we go. Okay, so you see that now?
Okay.
Yeah, you see that? Yeah, okay. So that's the new coil. It's very small. It's only 36 feet in total. It's 12 feet by filer, and then there's an added part that is 90 degrees out of phase, and that seems to capture the top of the wave. So I was doing some tests on it, and this crazy waveform happened. Can you see that?
Yeah.
It's a negative energy waveform.
Yeah.
Below the line. It's below the line. Whatever you're doing, you're not creating any pot. Well, you are a little bit, but majority of the power that you're creating is in the negative.
Yeah, it looks like constructive on the downside.
Is it at
Yep.
13.8 volts?
No, actually, it's at 12. I know it shows that on the meter, but my power increases. So does my frequency. I was only pulsing 10,000 hertz in there, but I was showing, I think, 340.
Can you go back to the signal in the beginning of it, Gerald?
Sure. Give me 1 sec.
I gotta get up for a second. Oh.
I guess I shouldn't have closed it. Sorry, my computer's taking me time to open it. Here we go. Okay, so you wanted to see the signal on the meter?
Yeah, just the beginning. It's just Victor showed a fractal last time he was on, and it had the same like overall form.
That part?
Show the meter now.
Okay.
Just beginning.
Wow, you got a lot of meters.
Yeah, trying to prove what you have. You gotta have everything needed, right?
Okay, stop it right there.
Okay.
The different waveforms where they were going like this. I'll say it. I can't even do it in the camera. One a little off from the other on a box. So like that. He had a bunch of them on there on his fractal thing yesterday, and he was showing it. It shows up right in there.
Really?
Yeah. And then yeah, you definitely have negative energy in there. Did you get a closer look at it?
Yeah, it dips down. I actually have some waveform pictures I can show you. Let's see here. I'll stop sharing.
Gerald, when you're doing your experiments, do you have a thermometer? You should be doing some temperature readings.
What? Oh, you mean for temperature? I do. I just haven't hooked it up in those.
No, but yeah, you should use it all the time and see if there's any difference in temperature. Because if I got my Renegade running really, really good, I can get anywhere from 5 to 10 degree difference in
Oh yeah,
temperature.
yeah. You know what? I will start using it from now on, just to show that. But you're right, because I get the same. Let's see here.
Are you taking your readings from the winding that's 90 degrees out of phase, or?
Yes, on that one it was 90 degrees out of phase.
Okay, well that I think what you're seeing is two phase. You're mixing. They're not 180, which would be the what's called phase conjugate.
Yeah, which I have in that coil.
Going at 45 to it almost, because electricity wants to happen at the 90s. So the phase is somehow affecting. I would think that the 45-degree angle somehow.
So before the transistors blew, here's what I have. I have the coil's 180 degrees out of phase, and I pulse both those, the primary and the secondary, which are 180 degrees out of phase. And then I also have a third coil wrapped in there that's 90 degrees out of phase, and that's what you've seen that waveform from.
Okay.
Hold on. Now I got it. Now I see it. You have it goes up, comes down right afterwards, goes up, comes down right afterwards, and then when they hit together, it makes a major dip. That's what you're doing. That's why I look like that. Okay, now I get it.
So now let me show you this next waveform that shows that it's in resonance and that there's current, but it's a crazy waveform. I gotta show it to you. Okay, so here I'll put this thing on here. You tell me what you think of this. Look at that cross pattern in that.
Oh man,
that's cool.
Yeah, that's so cool, Gerald. Holy crap!
That's
Marco's numbers.
What's that?
Victor? Looks like Marco's number patterns going around the toroid.
Huh? That's
yeah,
so cool.
Anything like that. Yeah, that is insane.
It did look like that. I never thought of that. Yeah.
Can you bring the peaks down, or is that what you were doing later on there? Oh,
yeah, that's what I was doing. Well, I wasn't bringing the peaks down as much as I was showing the the waveform when it's in microseconds, I think it was.
What frequency are you putting into the coil?
That I'm only putting in 100,000. So 100K, and I'm getting out 430K at 81 volts peak to peak.
I've never seen anything like that. That is so cool.
Makes me think of force fields.
Yeah, right?
Yeah.
Kind of like
on
blink
that
on and
topic,
off
I
in
was thinking,
sections.
you've seen the work with the rings, right? You're supposed to play the different harmonics in the rings.
Yep.
And I was looking at it going, oh, it totally makes sense then. Why matter seems to be solid. It's being harmonically reinforced, so that you have to break through so many harmonics.
Yep.
So if you could separate, like Sheila was showing, and see those patterns, we might be able to slip through solid matter like a longitudinal wave.
Just like the Philadelphia experiment.
Oh,
Right.
yeah.
Yeah, like I just don't want to be fused to a wall, but let me know when you got it up and running.
Well, the reason why that happened, I believe, is because when the generators were smashed, there were still people playing in and out of the walls. So the
Oh, that's
generator
exactly
shut
what
off.
happened.
Yeah, the power went kaput and they fused in it. So yeah, stay the heck out of the wall.
Yeah,
Yeah.
stay out of the other object's barrier is what it is. Because when you become barrierless, then when
Walking
things
through
come
it's
back to
one
normal.
Yeah, walking through it's one thing. Playing in and out of it, if you lose power, you're part of it. Right?
Yeah, well, if in those guys' defense, if you're one of those guys and that just happened to be the case, like
That's
out of nowhere, you're not gonna know what the hell to think. Like you're probably scared out of your mind.
You're not wrong. I think I would have stayed right where I was, hoping that it would all shift back.
Yeah.
I don't know.
All right. Do we find it a little ironic that they were going through walls, but not the floor of the boat?
Yeah, that's crazy.
Yeah, well, different
Because
thickness of
I'm
steel.
not trying to punch a hole in the theory and ruin it for
Nope.
people. I'm just
no,
saying.
thinking of why. Thinking of why. Because of time. If time happens at altitudes, then the diameter of the Earth matters. So if you want to try to do work in the future, you got to build a tower and put your gates in the two towers. No wonder they fell.
That makes so much
man.
sense now when you talk about the Tower of Babylon. Wow, you just blew my mind, Victor.
Time, the sun adds dust to the Earth and it gets bigger and bigger. Sometime in the future, its diameter is going to be huge. Its frequency will change.
So the Tower of Babel.
You see the Roman soldiers underneath certain churches or whatever. They say the soldiers are walking along with their feet in the dirt. They're at a different ancient altitude.
Yes.
Yeah.
So the pressure's
Yep.
at different.
I saw that, and
makes
that was exactly what I thought too. They were up to their knees. They were walking on the ground, but the ground at the time of the time
was
Are
different.
you aware
Yeah.
of flame dragging? Where a rotating object wraps time around itself?
Yep.
Rush research. They had to readjust the damn GPS satellites for frame dragging because they weren't given their coordinates right. They found out the planet's wrapping time around itself like a veil and layering it. That's why the causal rev is, oh man, so much is clicking in my brain right now.
That's how they made Project Looking Glass work. They can look back. They can look in front
The
of
time camera?
Yeah. Yeah.
Thank you.
Amazing stuff.
This is exactly why I come on to literally unhinge it and have people like, oh my God, it's clicked. This is the whole, I've said it every time. That's the entire purpose of my existence. That's it.
The aha moment. I love it.
That's it. You talk about the woo, and then it's like, wait a sec. What about obelisk? That could be relevant too, as far as like,
What?
out. Yeah.
They're pickup coils.
Yeah. Pickup coil.
Yeah.
Makes sense.
It's there to direct the energy and then allow it to flow through the obelisk into the ground. It's like the load that we talked about earlier.
Yeah, and I guess that's why if you're rich and you die, you have one above your head at all times, huh?
It could be
Yeah,
that
makes sense.
mass being that high in the air is pulling in electricity, and then the weight of the obelisk is putting pressure on something else piezoelectrically to maintain some kind of energy in the sarcophagus
I like that.
or
That's
That's
creative.
something anyway, a capacitor.
But then
What?
Oh, that's interesting.
But what though? Like, are we something like a stone coffin that they made? Like, isn't that what they made? Like their tombs out of was they made them out of granite.
Make that a granite.
Or were they time translators to get young again with the show?
Guys, I gotta head out for the night. I gotta get up early. Thanks a lot for inviting me on.
Thanks
All
for
right,
coming,
Mike. Thank you very much.
Mr.
Yeah,
Mike,
take
man,
care, guys.
be good.
Yeah, we'll see everybody
Mike.
Friday night. Take care.
Yes.
Bye.
Have a good night, Mike.
Good to see you.
Bye. Thanks.
Yeah, reactive energy. I'm going to look that one up.
Yeah, he does a lot with reactive power.
I know it's there. Eric talks
Yep.
about it. It wasn't in my research.
I get that. Totally.
Oh boy, that's an idea to think about.
I'm going to be looking up a pentaquark. I think that was my takeaway nugget of the day. I was like, wait a sec, that's cool stuff.
Yeah, I can't talk on that just because I was telling Victor earlier. I'm just, you know what? I'm not up on all that particle mass stuff and
Me neither.
gluons, quarks.
Well,
No.
the interesting thing was when I was talking to Nathan about the descent of matter to energy, right? And then I wrote my song that we played the other day. Like the way that I pictured it was exactly like those bits just simply all fitting together and then collapsing and cascading into a void that was created. That's how I pictured it in my head, you know? So it's just like all this energy that was perfectly still, it's fine, and it's all perfectly fit together like these little tiny bits, but not moving and nothing. And then all of a sudden, once the pressure started and the matter created, well, it all just fell to the matter in dispersion, void, and then just all these bits falling in. That's how I pictured it in my head, at least. But the question was, what's the perfect bit that fits together in that grid that could be locked solid until it's not? And that's the answer, you know, because it's fractal. It could be as infinitely small, but yet all still part of the same, you know, collapsing
Could be
in.
infinitely large as well.
I was thinking about that on one idea. You're aware of like the Star of David, right? It's made of two triangles.
Yep.
So like the Cantor's dust, the triangle gets the middle third removed, but instead of being empty, they put in a motif of another triangle. And then the motif would spread smaller and smaller until you have this infinite snowflake.
Yep.
If you take that actual infinite perimeter and were to tilt it on its side, you would notice that it is not a solid line. It is actually made up of two Cantor's dusts. So all those points in powers of two are spread out to make what appears to be a power of three. So it's actually individual little points like electrons spread out over an infinite surface. So it's made of two charges. The two triangles that make up the Star of David. It actually grows. The math says that star isn't a solid object. It's made up of two rotating fields that are Cantor's dusts. They interlock to appear to be the snowflake.
Wow. The Merkaba.
Hello, Nathan.
Yep.
Hello.
Lulu.
Hello, Lulu.
Hello.
How are you guys?
Good.
Great stuff. Great stuff. You know, like we're talking about elementary particles. There's 17 of them. Wouldn't that translate to 17 primary or elementary frequencies that combine into bigger things and then combine into bigger things till we reach something called an atom-sized frequency? Yeah.
That makes sense.
That's what they say.
Well, I mean,
Well-
they're building blocks of an atom consist of 17 possible configurations.
If you look at Sheila's work with the coherent waveforms, you know, she gets those coherent waveforms, the standing waves, only when she combines, you know, those frequencies in the set.
Yeah.
It's sonic reinforcement.
I personally
So-
think it's fields, not particles.
Just a theory on the particles, because it was something that I actually heard you talking about that the other day with Mike Does about the fundamental particles. You know, I mean, look, it's just a theory, but if I'm under the summation, in my belief at least, right, that everything is effectively result of a wave at one point or another. So if you think about wave interference, okay, and you have you know, constructive wave interference that takes off the top little portion, okay, of a wave. Okay, that's going to be an electron. That's an electron, right? Now, every other fundamental particle is a different result of wave interference. That's just my theory of it. Now, as it falls down the system and these accumulations occur, then yeah, you have the condensation of this energy into greater and greater amounts that ultimately create mass in the end. But you know, I mean, it's just a long way to fall. You know, they have to go through different cycles of accumulation and density in order for this to happen. But that's my opinion of how fundamental particles are differentiated, and it's also just again an opinion. I'm a total dope. Literally says I'm an idiot.
Well, I mean,
Yeah.
Warren York, for example, Warren York had this theory that the electron was made of 918 photons, which is a really it's a really interesting concept when you break it down, because the idea that you take 918 photons and he gives out the wavelength and the basic energy density of those photons that equal the total mass energy density of the electron, and how he got to that number, I mean, to be honest, going through Warren's work, it's way out there. He refers heavily on Dirac and other well-known physicists whose work, in my opinion, is pretty solidly founded and is now foundational in terms of the rest of physics. But the idea that matter is made of light wrapped up on itself, I don't think is that far of a cry short of what we're actually looking at, because when we really zoom in, what we tend to see is that matter acts like light, and that light seems to be more fundamental than matter itself. So if we consider that, we have to have also this other thing. Okay, so we can't just have light on its own. There can't just be a universe made purely of light. There has to be this other background field. That field by Tesla's word was called the aether, now referred to as the ether. And it's got a lot of different interpretations, but the luminiferous aether is specifically one made of electromagnetic waves, both electric scalar fields and magnetic field vectors. And so magnetic fields are torsional in the fact that they are curled. They are all closed loops on each other. And electric fields, being scalar, can be configured into any various gradients, being 360 or omnidirectional, or they can be focused into a fine beam, like in the example of the scalar beam from Eugene Podkanoff. And that was a gravitational device that used an electron impulse from a superconducting dual-layered disk through a magnetic field onto a target plate. And the end result was that when the electrons that had accelerated through the electric field inside this device and also spiraled into cyclotron motion through the external magnetic field that was applied to their trajectory, when they finally hit the target plate, they dissipated all of their momentum, and the target plate itself was restricted from motion, so the momentum carried through as a wave that now has been coined by Boeing under their patent called matter wave generator as a momentum, or as a matter wave, which is basically the same as the momentum wave that we look at from people like Henry William Wallace, for example, who look at the variations in momentum and energy coupling between two rotating masses with odd nucleon spin densities. He used brass. He also used a variety of other materials. Thomas Townsend Brown loved to use tantalum and any odd nucleon isotope of your normal matter. Basically, anything that has an odd balance of neutrons versus protons will experience a difference in gravitational inertia versus inertial acceleration. So that means things don't fall at the same rate. It's a violation breaker. It means that Einstein's basic energy equivalence principles don't apply in these situations.
Can I ask a question?
Yeah, absolutely. Go ahead.
If I understand you right, then is there any evidence then of time dilation with the gravity acceleration helping it?
We haven't been able to measure it, and I believe it's because the time dilation is happening interatomically. It's due to the refractive index being modified in the space where you don't have a correct number of neutrons to balance out the physical mass energy density of what we considered in all of our experiments for how fast something accelerates under a gravitational field. So let's say we take some normal matter and non-isotope, meaning that it has a balanced number of neutrons and protons. We drop that in a gravitational field, we measure how fast it goes. 9.8 meters per second, right? So it's a pretty, basic measurement that the common materials have. But if we take something else that has an odd nuclear ratio, and we drop it in that same gravitational field, as in we drop something with an odd nuclear ratio. Let's say we take tantalum, we separate it out into its isotopic parts and its non-isotopic parts, and we measure them on a basic scale, a high precision scale, and we measure them out to be 10.0000 grams each. So the two samples are identical in terms of their gravitational weight when they are not accelerating. But now we both drop them in a gravitational field. The isotope will rise up in an enclosed box compared to the non-isotope, which will fall at the same rate as the steel box. The reason for why is that the electric field has an effect on the localized region of space-time surrounding it because it is not balanced out by the correct amount of mass from the neutron. And so you end up with, in this case, what Brown calls an inertial isotope. Is it inertial isotope or gravity? Yeah, I believe it's the inertial isotope side. But it falls slower. And it has more inertia under acceleration. So it tends to rise up inside the enclosed box. As the entire box is dropping from top to bottom, you'll have these two elements, and they should drop at the same distance. They should fall down evenly, but one of these is actually going to drop a little faster than the other one. And you'll see that on camera. So there's been tests to show that there's purity violation and equilibrium violation using different elements that have different isotope ratios. It's just one of those things that's not currently looked at. Aluminum also has a very high degree of isotopic elements, and bismuth is almost 100%. So there's a reason why you hear about bismuth used in flying saucers and that kind of stuff for this technology.
Interesting.
Good info.
Very interesting.
That can be made into an alloy then, right? And would the property carry over to the, oh, dude, thank you.
Yeah.
So the physics.
I want to meet you someday. I want to talk with you.
I can get you my info. I'll drop it in the private chat.
Or hit
So
Nathan
Jeremiah,
up.
the physics of the particle inside the box is follows the relativity theory of the physics, of the local box. So it has to abide by the physics.
In this case, the experiment I'm referring to, it didn't use a particle inside of a box. It used a physical block of material, a physical block of metal. In fact, it used I think it was 7 different samples, if I remember correctly, that were all placed on the bottom of the box. The box was dropped from the inside of some very tall tower. I think it was like an old nuclear power stack or something along those lines, but something reasonably tall. So the box was dropped. And there was a camera inside that recorded the entire drop test, and the box is enclosed, so there's no airflow around, what's going on inside. And these various elements, some of them.
What if it's the airflow?
Well, what I mean is there's no airflow inside the box because the box itself is completely enclosed, and so there's light inside the box because there's a clear plexiglass window, so light is getting in. And there's a camera inside the box. And the camera records that these elements don't all fall at the same rate. So these 7 different elements, most of them stay down, but some of them during the course of the test, they start to actually rise up, and some of them stay at the floor level. So it's really interesting to consider that, maybe this basic very old test where something was dropped off the Tower of Pisa, a feather and a bowling ball are a very nice analogy when we try to consider that everything falls at the same rate under a gravitational field, because those are mixed elements. But when we take very pure elements that have high isotope ratios, they don't fall at the same rate. And it was something that's not looked at in physics today, and something that needs to be looked at, because this is how the craft that, say, visitors from other places would try to isolate their isotopes and utilize their unique properties in producing gravitational acceleration that's unusual for us humans.
So my question about this experiment would be, did those 7 elements that were in the box, did they all have the same decay rate?
No, none of them have the same decay rate, because they're all different elements. They all have different decay rates.
And they all fell at different times, correct?
Some of them stayed on the floor of the box, and some of them rose up inside the box. My guess would be that the ones that stayed on the floor of the box may have been actually falling faster than the box itself. But we wouldn't know it because they had no room to move down. They were already at the base, so they couldn't move down.
My question relates to time. That's the only reason why I asked.
Like the box drop test, the element should have started in the center of the box. There should have been something that just basically tilted down and left its way, so they could have fallen. The ones that were heavier then, or they fell faster in a gravitational field, they should have been allowed to move down, but they were already at the bottom of the box. We couldn't see that in the experimental video clip. And the ones that were falling slower than the rest of the enclosure, they moved up inside the enclosure until it finally hit the ground.
Now, was that related to the weight of each element, or was that related, and this is where my mind goes,
it wasn't directly correlated to the mass. It wasn't directly correlated to the mass. So no, not the heavier mass elements didn't necessarily fall faster or slower. It was based on their nuclear spin ratio, their natural abundance.
And that's what gives me another question that I don't think can be answered. But my thought process is, because there were different elements and they're at different decay rates as they're falling, because of the I wiped it out, darn it. Because they're falling at like a different potential, in the sense where they have different potential in time, because they are different elements decaying at different time rates. That's why they came down at different levels while they were falling. It's just a thought.
No, basically what you're saying is, yeah, if they're decaying, then they have a dispersion, or, there's basically a damping factor. So Todd Desiato he's working on a new theory, and I really like where he's going with it. And you'll hate that he's using the assistance of GPT, although rewriting everything that it says in his own words, because of course I know how you feel about GPT.
Yeah, I think if you have to use AI, you're not smart enough to be doing the work.
Well, he's not. He
Sorry.
I know. That's why I say, yeah, I know how you feel about it, but
sorry.
He doesn't have to use it. He's using it to clean up the wording.
That's what they all say.
And so the wording is actually rather important. Regardless, this idea that there's this damping factor, and if you take a gradient of energy that's very focused, and you turn that gradient of energy into a dispersed field, you end up with 2 very different forces in terms of your field vectors. So your gradient of energy has a trajectory. It's moving from one direction to the other. When it splits apart, that gradient that was pointing straight upwards now points in all kinds of different directions. So which is your net vector for the body that has contained this gradient of energy density? Well, obviously it's in the direction that the gradient was moving, because you dispersed it. And through that whole damping factor, the dispersion, that you put in energy in one single field vector, and this is important to you old man builds, you put an energy in one field vector by using electrostatic fields to polarize the center plate, creating a net polarization along the nuclear magnetic moment through the electric field, with the top plate being positive and the bottom plate being negative. Now you've excited the center plate using AC, and you've disrupted the field gradients because you're effectively modifying the field connection lines between the top plate and the bottom plate based on the potential on the center plate. When you disrupt that, you're taking the gravitational field, which is already trying to polarize every single molecule inside the center plate and every single atom inside the center plate. They're trying to pull along that certain gravitational field vector, which means that what you normally have as a symmetrical recession is now being squeezed, and it's actually slightly wider. Instead of being more upwards, it's now wider because it's squeezed into the gravitational field.
Victor's cones.
Right. When you disrupt that field, that can widen back out again, and you can dissipate the energy through the damping factor of the stress energy from the electric fields that are being superimposed thanks to your inputs. But something else has to happen. You have to have a strong enough magnetic flux in order to disrupt the field gradients inside the center plate. And that magnetic flux comes from the bottom magnets. So
Yeah, you get them too strong, though, it ruins it. It ruins it. You
right.
can't get them too strong.
So it allows it to go from stored energy into dispersed energy. And in that very moment, that's when you can actually get your lift, because now you're taking all this stored energy that was tilted up in one single field vector into the gravitational field, and you're basically allowing it to twist and disperse off sideways. And if you look at, I'm trying to remember that guy's name. He's got this diagram of combination from the top and bottom and annihilation out the sides, or dispersion. But
is there any evidence that those different speed rates could somehow be giving a lower state of entropy that could therefore be tapped by the higher state of entropy that we're causing? Because the lower entropy state would give us...
You've got it.
That's how my system works. It's actually in my theory, written into my book. Entropy is, I want entropy. I want to use the fact that as the energy is starting to degrade, I'm capturing that flow and I'm reversing.
I had a question, Jeremiah. I think you probably are one of the few people that could answer this. Do you know the double slit experiment? The one that, they shoot a photon. Okay. All right. What is the distance between the slit and the detector for you to either for sure see 2 or see an interference, start to see an interference pattern? What is that distance?
The answer to your question is it depends on the wavelength of the input, and you can use things up to micrometers for electrons. Okay. If you preferably want nanometer slits. Technically, if you widen out your beam, if you have a lens that spreads it out, you can still get the interference pattern. If you take a look over time. Even with slits that are far too spaced apart for the wavelength. The key is that the slits need to be very, very narrow. So if they're wide slits, you won't get any effect. They have to be extremely narrow, and they should be just about the size or smaller than that wavelength that's going through them. And for physical particles like buckyballs or electrons that also show wave interference, they should be pretty close to the size of those particles. Otherwise, if they're too large, you end up not getting the interference pattern. See, there's actually a wave interaction with the wall itself of the slit. And it's
the distance, does that distance matter where the detector is from where that's like, to either see the interference pattern or not? If it's close, you won't. If it's further,
so you probably would. You have interference fringes, and if you look at them at an angle, they cross. So you may have a fringe here and another one up here, and one here. So they'll spread out. The farther you get away, the more fringes and interference patterns that you get. So the closer that you are, the more refined and the stronger the individual fringe patterns will be. So if you get at one range, you're basically going to have just 2. Let's say you put your impact plate right up against the slits. Well, you're going to have 2 lines, right? Because there's no space for the waves to interfere. If you move it out one wavelength, you're going to start to see a slight differential. You're going to see a fringe in the center, and you're going to start to see the appearance of two fringes on the side. You move it out a couple more wavelengths, and you're going to start to see multiple fringes that are showing up along there. So the distance and the resolution, the number of fringes, depends on the wavelength and the actual distance between the slits. But obviously, if you put your plate right up against it, you know what you're going to get. You're collapsing the wave function beforehand.
Oh, no, I get it. No, okay. I don't know, for whatever reason, I completely misunderstood that. But the lighter ones would be the back ones, the ones that already hit this, and are interfering back. The ones that are like solid ones would be the first phase ones.
Right? That's great. That's where you're getting your first wave coherence pattern.
Okay.
And that's where they're all basically impacting the plate at the same time, and their wave function collapses when they hit the target plate. So that's where you're actually seeing that light finally being recorded, or where your particles are hitting.
Because I looked everywhere online to find an equation for how to calculate that distance, and nothing. I've tried every form of search,
No, it's funny because they don't bother to include that stuff in the papers, and the reason for why is assume that if you're already doing a double slit experiment, that you also understand that the wavelength and the slot depth and width, you understand that those are the parameters which set your distance. So it's just assume that you already know that, therefore it's not included. It's sort of like the assumption, if you're reading a manual on how to do, a wide path stick weld, that your welder is plugged in. They don't necessarily tell you that you need to plug it in, but it's one of those things like, well, we assume that you know this, so we didn't include it in the instructions and we didn't include it in the paper. We just assume that you know it.
Yeah, but it's a viable measurement that, you should have, that, could have its variables on this side and variables on that side. So,
right, no, but it's funny because what you've really pointed out here is the severe disconnect between the academic thought process of people that operate within the educational system and the rational thinkers who operate by a process of elimination and use deductive reasoning, right? Because you can't use deductive reasoning in the academic community. It doesn't work.
There isn't any.
No, there's no deductive reasoning. You can't get down to the bottom of it because it's based on whose shoulders you're standing on and whose shoulders they were standing on and whose shoulders they were standing on, and you go all the way down the chain, and it's basically a big centipede. If you know the reference,
nothing done because they're too busy writing. You can't get nothing done because they're too busy writing papers about each other.
Right, exactly. So
peer review, right?
We get the experimentalists, and the experimentalists, like those of us here today, are the ones who really push these theories. And occasionally, somebody will get on and they'll be really overly confident in the fact that they got grants because they filled out the right paperwork and they did the right maths, and they're like, you guys don't know anything and you're a bunch of idiots, and you don't know how to possibly view this, right?
Meanwhile, they're watching us for pointers and tips.
Exactly. And then I see stuff that I put out there show up in papers 2 months later, and it's just one of those things like, well, this has happened 10 times before, big deal. It's like what Tesla said. When Tesla was interviewed by a newspaper writer about what he thought of the fact that Marconi was being accused of using his patents, he said, "Go ahead, let him steal those patents. I'm way ahead already." Paraphrasing here, so he already knew.
Yep.
Well, everything everyone knows is just a dream someone had at one point in time, and the more accepted it is, the more mainstream it becomes. Like, think about how many times science has changed over the years, and it's all been stuff that somebody's already thought of that actually precedes that. It's just sort of how it goes. That's the evolution of this process, and I think that's where it gets really broken with the academic system at this point, though, is like, it seems at this stage like it used to be like, the church said you can't, look at these certain things. You know, there was spirit world, and then there was matter world, and it's got, you know, the church is the spirit world and science is the matter world, and you stay on your side of the line. And then, you know, there was a little bit of time where it started loosening up, where things actually started to progress. And as that progression was made, look at how fast things accelerated. It brings you right through the Industrial Revolution. It brings, you know, discoveries in Egypt, and now all of a sudden, in, you know, at the same time as the Industrial Revolution, people are rediscovering all that stuff. You know, at that same exact time, Tesla is, you know, figuring out, you know, all the principles that he figured out that we now use, but then it all got swept under the rug. Defund him, make new rules. You know, Einstein's out. Now all of a sudden you're stuck in the box of, you know, relativity, and then he brings in quantum mechanics into the fold, but they don't really, you know, accept it widely at that stage, you know. And then they start realizing that there's so many flaws with relativity as it is, you know, with unanswered questions, that they have to start filling the gaps. And you want to know something that's, we don't know what it does, but we're going to give it a name and a function, and therefore it exists, therefore it's something. But
That's how I feel about particle theory.
But if you mention something that is objectively true, that you could show, like, well, where does this come from? Look at this effect, and be like, and here it is, and I'm going to give it a name. They're like, but that doesn't fit into the laws that we drew, so therefore it doesn't exist. We won't review your paper. We won't look at your experiment. And chances are, if you make a big stink about it, we'll shut you up. So,
you know what? Academia failed when they brought funding in. When you have to apply for funding,
always.
Right, academia failed. It's all about the search for truth and the search for new inventions and new ways of looking at life. Not getting paid to write a paper. Give me a break.
Yeah.
Maybe I'm wrong, but I think that's pathetic.
I mean, I'd like to believe that there's a lot of very, very, very sharp, knowledgeable academics, okay, who have questioned themselves and everything that they know this stuff, but have to shut up because at the end of the day, it's feeding their pocket.
They know it, but they're not going to step out of line.
But that's the thing, though. Grow a set of gray-haired balls and step out of line and get the shit done. Otherwise, you're just towing the line like every other dog.
Yeah, but haven't you noticed there's a lot of them out there that drank the Kool-Aid, dude. Like, a lot of them actually believe this stuff.
Have you not noticed that most of them will, at the end of when they're about to retire, expose a lot of, you know, hidden science? Like during their working, you know, years, they're not, because they're banking on that, you know, paycheck, but they know the truth. And yeah, and so at the end, when they're right about to retire or after they retire, they, you know, divulge all this like scientific information. And it's like, well, why didn't you say so when you were in that position before? You know, I've seen that more often than not, honestly.
I don't think that academia has the credibility that it used to. Once upon a time it did, but MIT's gotten caught lying, so is Harvard, so is Stanford. So it's like, where do you go when you're looking for the truth? Well, the only way you can find the truth is through experimentation and talking amongst people to try and bang out the truth, to figure out what's really going on.
Okay, so
you're gonna rely on some guy who's writing papers.
To back it up, Gerald, funny story. A buddy of mine, whose name I won't mention, who built the first self-propelled ion aircraft that was vertical lift, which you can probably figure out who I'm talking about based on that information, had built it many years before MIT's ion-powered plane. After MIT was credited in multiple news media outlets as being the first to build a self-propelled ion-powered aircraft, he submitted the fact that not only had he already done this, but he had patents that were approved and a fully fledged company that was working on solving this problem.
Yep.
They got back to him, said that they would forward it to the right people, and then he never heard anything back. So, you know, he messaged again, never heard anything back, messaged another time, and they told him that they were not interested in speaking with him finally on the third time. And that was where it lay to rest.
But he holds the patent.
But he holds the patent, and the patent is dated many years before MIT's big release of their ion-powered plane.
See, academia is supposed to be about creative ideas. It's supposed to be about forwarding consciousness of men, not sucking in all that greed and getting your name on a paper and classifying yourself as a so-called whatever.
Right. Well, here's the worst part. The worst part isn't even for us as experimenters. It actually falls on the students, because what will happen is a professor will put forward a thought experiment, a project, and offer credits for it to the students. They'll work on it. They'll experiment with it. They'll spend their free time, their extra hours, in the laboratories working on this thing. They'll develop a technology and make it viable according to the parameters that were laid out by the professor. And then the professor's name will go on the paper. The students won't be mentioned. And the rest of their lives, they'll have no trust for any kind of authoritative community, because it was stolen from them. And this creates a whole revenge plot of, I'm going to become a professor and I'll do it too, or I'm just completely out of the system, so I can't operate within the setup that was laid out for this kind of productivity. And it really creates a huge divide. The fact that the professor has to steal content from his students because he can't come up with something on his own that meets that same level of intellectual prowess and genius.
Not for anything, but this is where the thing really goes full spectrum into the deep, dark psychology aspect of how just the egos of all this stuff. It really is the destroying factor of it all. Like, I mean, it really is. When you worry about yourself and those close to you, and you care enough for others, like, you end up being poor in some ways and rich in many others. But like, tell that to people, because like, right, they spent their whole damn life studying something, trying to crack some kind of code, and they do it, and now they have nothing to do with it. And I can understand how that's bittering to some people. But like, what you do with that is, that is the alchemy of the self,
But now, if you've come up with something, or you've cracked a code, and you go to put it out there, 9 times out of 10, academia gets nervous, gets their hands on it, takes it for themselves and slaps a name on it, or they hide it for a while and bring it out later. Like the thunderstorm generator, for instance.
Mm-hmm.
Malcolm did an amazing job, but it's Paul Pantone's work that he's working with. So when Paul Pantone went to jail, all his tech disappeared. And then all of a sudden, 10 years later, after everybody's forgotten his name, Malcolm Bendall comes out with the thunderstorm generator and barely mentions his name.
Right. Well, there's a reason for that, too. There's a reason for that. Okay.
No, I know it was explained. You don't want to bring everything out at once.
He's also came out with the plasma unification model and the turbine-less, or the vortex turbine.
He also had to rebrand it to not serve the same fate too, and like, there's a little bit of an association issue with it. That's that's my pull on it. It's like
that's exactly it, right?
That to me last time.
It's an association issue, and so if I were to create some kind of cold fusion system, and I were to mention that it's based on the works of Pons and Fleischmann.
Yeah, you automatically. I get that.
Yep, automatically, right? If I were to create a water splitter, and I were to say it's based on Meyer's work, automatically.
Yep.
So I won't mention those kinds of names if I'm working on that tech, even if it's basically a copy of it. And the reason for why is these people were, we've seen what happened to them. We've seen how systems have destroyed them, and in Stan's case, literally murdered him. As far as we speculate, I know that's a conspiracy.
He had big
side, but right.
He had big kahunas. That's the thing.
Mm-hmm.
These guys came out and stood up. They had kahunas. They said it how it was. Right?
I was trying to tell Ben a little bit about this the other day, but it was in the chat, and I really couldn't get through my message in the chat like that. What I was saying is, he had said that he had went, outside, he is outside the box like the rest of us, right? But he went inside the box just to get a little bit of feedback, but presented it in a way that he would, and rightfully so, like he would to any of us. But then it's like, then you got to know, right? You got to know, like, where you're, what you're going to get when you're sharing it in certain things. It's okay to want like the information or the opinion from inside the box, but if you're going to go in there, you're going to have to present it in such a way that is ambiguous, and you're not going to want to make claims. You know, you're just going to simply want to say, hey, listen, this is the setup, this is how it is, this is what I'm seeing. Thoughts?
It's all
You
a
know?
basic principle, though. It's all the same thing. I get what you're saying. Maybe it just irritates me.
Well,
Like,
it
it's
is
just
no,
that-
you are right, because it is irritating, and rightfully
yeah,
so.
that
But,
guy went to
but if you
jail.
want to go and get information from people that might have it inside the box, that's what you have to do, or else you
Yeah.
have to expect what's coming down the pipe. That's
Right. Basically, all you're saying is you got to meet them where they're at.
you got to meet them where they're at, and you don't make a claim. That's the point. You know, you don't say, hey, look, I'm pulling XYZ out of here, so therefore I have this. You have to say, hey, listen, this is my setup. I'm testing this, that, the next thing. These are my results. Thoughts.
Oh, I get that.
Also, the thing with Malcolm you have to remember is he's from the oil industry, so he knows how they operate.
Yeah.
Guys, we're getting reverb somewhere. Somebody's got something on.
I turned down my volume.
I don't
Mute,
here.
and let's see if that takes it away.
Oh, we're good now.
Maybe that's the other part that bothers me. He's from the oil industry, and I've already had a run-in with a member of the oil industry trying to buy my work. I told him to go pound sand. But I mean, I don't know.
I have a question. Is it?
He was an oil prospector. Yeah, he would basically use his geochemistry background to go and find oil for different companies.
What's your question?
The guy I discussed with was the brother of the owner of Shell.
Yeah. Okay. So Lulu has a question.
I was thinking what you said. Like these students, do the work, and then the professors take credit. But aren't computer systems nowadays, like they have AI in them to the point where they can pinpoint, when that word or that, wherever the student was working on that project, and it timestamps it. So even if the paper later gets published at a different date, but it could go back and, where did that ever exist, and what computer or what IP address or this, and it could tag it back to its original creator, regardless
that
of
would be nice, and I understand what you're saying. Okay, you're thinking about the legal system. The legal system actually does tie order of events to reciprocation of, justice. In this case,
Right.
It's a private institution. They're not a legal system. They don't have to go in order of events, and there is no justice. They operate on their own system, and if they say that something that happened after the fact, if effect happened after cause, effect is perfectly fine to be the only thing to consider. So they don't have to operate under the same rules and regulations as a proper legal system. And so there is no reciprocation for a student, even if that student can prove directly to the dean that the paper that they wrote and submitted was done before the professor submitted theirs and got full credit for it. There is no reciprocation. The student doesn't have the credentials. The student doesn't have the tenure. They don't have the ability to submit to the big scientific papers, and there is nothing that they can do about it. So
okay, all right, but now listen to this. What if we launch an AI that doesn't see, like universities as hierarchy, but sees the data? What data has hierarchy?
You're
You
assuming
understand?
that the professor is going to actually implement putting that data in.
Right.
No,
He's assuming like
it-
an honor system where there is actually some sense of honor and
No honor
some
in
sense of accountability or integrity here, but those things don't exist in this system.
No, there's
unfortunately.
no honor in academia whatsoever.
Not to mention, any student taking that posture against their university and their professor is socially damning themselves
wait,
in the industry that they're studying to be in. Like, socially, it just doesn't work either. Even if you have a timestamp and the proof and the this, the that, you're destroying yourself before you even have a foot out the door, and nobody's looking to do that.
Okay, let's just say again, it's not an accountability. It's not like a judgment system. It's not a law system. I'm just saying natural numbers, if we were to extract all the data from all the devices and chronologically put them in the order that they were created, wouldn't that create a lot of discrepancies in the data that we take as, this was before this person came? But if we, not have the bias of law and, the professor and student, no, just raw data and, put it on the timeline.
Yeah,
Wouldn't that then,
Right, but
So,
the
you know?
question
but
here,
that could be
Lulu,
manipulated depending on how you run that data, what data sets. If you're talking about running large language models and so on, you could get raw data, but who's looking at it? And if you're asking the AI to be the one to be the analytics of it by input of the large language model, it could be manipulated. So I mean, I'm going to tell you as a matter of fact, I could go into the best, publicly available AI that there is, and I could get it to tell me whatever it wants to by manipulating it. I've done it 1,000 times. I'll continue to do it, and it's fun. But I'm not saying that there couldn't be an AI that exists that is beyond this. But I think that the nature of an AI, if it were to achieve the ability of a human's analytical skills, even at the highest levels, even the highest level individuals can be manipulated. So you're never going to have, the nefarious like acts of people being the ones that are ultimately being the ones requesting the data and gathering it are ultimately going to be the end result of the analytic system. And it comes down to who's the one doing it and what's their credibility versus anybody else's. The whole thing is throw your hands up in the air and that's it. I mean, I literally,
Yeah, so
you could convince like a GPT to tell you anything you really want to validate your results.
ultimately, academia needs to be like the system of academia needs to be destroyed and rebuilt from the ground up. I don't mean destroyed in a bad way, but I mean like absolutely changed. The professors have too much power in the sense of what they define can be researched. They tell people how to think. They tell them where to look. They tell them how to look. That's not school. That's not learning. That's indoctrination. That's go to military for Pete's sakes. You know what I mean? I don't know.
Yeah.
I could be wrong, and hey, I apologize to those if I'm insulting anyone. I don't believe that the people in academia are wrong. I believe that the system is broken.
Yeah,
100%.
it's peace. It's all peace and love. It's not computers or the analytics or anything in your situation that's the problem. It's the people. The people are the problem. And if
I
it's
mean,
the people that request this change, well, who then, and what does it mean to who? Because that's the exact same situation that we're saying with AI, without AI. This one looking at it, that one looking at it. It's all the same.
and academia is a really nice foundation. You start out, if you stay within basically the parameters of what you're being taught, you're gonna learn the baseline, and you'll be able to do what we've already known for well over 100 years. So get that under your belt and understand that every single parameter that you've been taught within all those things that you were told were constants, they're all variables, and now you start your real journey. So
Yeah, academia is about towing the line. It's not about learning much.
I don't know, because I'm going back.
Past that point.
I'm going back to school for science information technology, but I have to write what is the purpose. I'm trying to figure out, different thought ideas. What would be the purpose of why do I want to go back into this field? What would be something, so I'm going along those lines. It's to capture true history of accounts rather than the made up ones.
I was gonna say, if you want a golden star in your paper, just say you want to learn how much of a genius Albert Einstein is.
No, I want to do something that is completely different. I appreciate all the inventors and all the scientists but at one point I would like to do something that is accredited to me, not just to, the olden times.
Well, here's the thing about entrance like that is the perception of the person reading it. If they know the curriculum is XYZ, okay, really for their institution, they want the person that's going to follow the XYZ. Now, what you go and you do with that information after you're out of there is totally up to you entirely. But if you walk in there and you start saying that you think the wheel is broken and you want to get the information in order to fix the wheel, all they hear is friction and somebody who's not going to peg well into their little hole. You know, that's sort of it. You know,
Yeah,
being
maybe you're
devil's
right.
advocate because you're curious in classroom settings and so on, you know, like that's counterproductive to their educational process.
Maybe.
You know, and frankly, between me and you, like, it's not, and even if you're 1,000% right, if you were in that situation, they're going to make you feel like a fool publicly in front of everybody the moment you start bringing that up. Because again, this school is not about, you know, breaking the mold. That's what you do after you get the information and the credentials. You know, school is about passing tests.
Yeah.
That's it. You know, so
By the way,
you know,
Gerald,
your personal
Ian's looking
goals
for
and
you.
educational goals, they're, you know, if you separate them in your head and keep them in perspective, then, you know, I think it's going to be great for you, you know?
Yeah. But you know, like at the end, like your essay has to be something original. There's got to be something unique, you know, for like this field is a systems field at the end of the day, and it gets to have, you know, anybody educated in that kind of field would have access to a lot more things than the average human being, and whether it's in research or information or even, you know, assignment of things for people. So you know, you have to have a bigger goal than just to learn whatever is currently there. You have to also, you know, put a
Sure,
plan
but
for,
remember,
you know,
if you're
what are you going to do for the
Pollock and you're
future
in
of
art
this.
school, you know, if you're Pollock and you're in art school and for your final exam, you take a whole bunch of paint and throw it on a canvas arbitrarily, and you're like, this is the next big thing. They're not going to see it that way until proven otherwise. So, you
Are
know,
you kidding me? I've seen it in art gallery. That's what
when
it
it's
looks
super
like.
creative and off the chart of what you've learned, and there's no direct correlation, you know, that's where you got to be careful. That's all I was saying, you know, because if you're Andrew Pollock, you know, fine art school, you could paint a beautiful painting, but if your final exam is this next big thing that's not realized yet, you know, that's where it gets a little dicey.
Right.
All right. Good thing I stopped going to school a long time ago.
Amen.
Oh.
Never stop learning.
One thing
they
about
they
school,
sent me
I-
home more times than I got to go there. They just pointed to the door and said, "Get out. Just you belong over there." Yeah.
Nathan was
Yeah.
Spicoli.
I'm serious, man.
Oh, dude.
Oh. I think my senior year, man, I only spent like a couple hours at school. And then the rest of the time I just went home. There was no reason. I mean, if you could do algebra 2 and geometry and pass them on home studies and just go in and take the test whenever you want to, God, it doesn't really matter if I go to school or not. I already understand it. Okay, I'm way past you, man. All I got to do is go into English class, put in a bunch of high-fluting words, you know what I mean? Look through my thesaurus, and that's it. That's it. You got 5 sentences, and you construct it this way, and you can write an essay all day, and I don't really give a shit. Okay? I never have. Who cares about writing all that garbage? Okay? It's just dumb.
Well, everything's got its place. You know?
but
it's to suck
when
up
your
time so
gravel
they can-
fire lifts off the ground, you're not going to write a paper?
No. I don't even know that I'll show it. To be very honest with you, I just don't know.
So they don't come and take it?
Well, that's exactly what they do. You got to understand, there's 2 Air Force bases right next to me. So they'll be in my house in like 5 minutes. It's
true.
Yep, pretty much. Can you send me a paper letter that it works?
Oh, I'll let you guys do it in private.
But now, Victor, I kind of wonder. Okay, so let's say I get mine flying, and then I write a paper. Who's gonna listen? Like, who's gonna read it? Academia is for writing papers is for your peers, right? Am I correct to assume that? Or
it would be us. Us to break that paradigm.
I get that part. I'm definitely writing something for you guys. I'm already like 98% done. I just have to finish.
It's all about the title. You've got to give it something that people are already searching for. I mean, if you give it something obscure, like you talk about hopions and, tiny little magnetic structures, probably not going to get too much public interest, probably not going to get the interest of a lot of people to review it. You talk about a new way to do something and just start it out with a new way to, and then follow it in with, that a new way to approach gravity, a new way to consider energy extraction from the ZPF. That kind of thing, that type of title, it'll get attention. And so it comes down to the title.
Interesting. Okay.
So like capture words, like words
Right.
that attract, yeah, okay.
And in this case, you're not talking to an algorithm. So this is not like, YouTube optimization or tuning the algorithm there. In this case, you're talking specifically to academics and scientists, mathematicians, theorists, and physicists who are looking at this stuff, and you're trying to captivate their interest. And the one thing they all share in common is they want that new thing that puts them ahead of everyone else. And starting out with a new way to is that new thing that might put them ahead of everybody else. They have to read it. They've got to, instinctively, intuitively read it, because
just to get that,
it might be that thing that gives them the advantage, right?
What a bunch of suckers.
Right. I know,
so
I'm
this
sorry.
could be
I'm just being honest. Though.
Well, Gerald has Project Blue Book over there.
Oh, we gotta go, Gerald.
This is the book that tells you how I built my coils, what they're based on, the geometry, the numbers, the math, the everything. So this could be considered a paper. But I mean, it's like
that's the first book they're gonna take when they show up at your house.
Well, there's copies. Go ahead, you can have this one.
I do that too. I put all my stuff in at least 3 different forms so that I can. Yeah.
Yeah,
I got
got
a question for Exotic. Could I ask you a question?
You can
Are you
ask me
familiar
whatever you
with
want.
icing spins? Magnetic icing spins? Are you
Icing.
familiar with icing spins?
Are you
A
talking
magnetic
about?
domain called an icing spin, ISING,
No, but let me take a look.
or
on
spin
the
glass. What a spin glass is?
Yeah.
Okay, I'm familiar with spin glass states, not icing spins as one of the particular states. I'm looking it up now, though.
I was just wondering if you had an easy way to understand what an icing spin model, how, or if it's the same thing you were talking about, spins on the molecules of different elements would be lower entropy.
Well, it's funny, that ties right into the rock and that whole discussion. I don't know if you guys caught that, but
Yep.
I mean, I can read it. So for people who are wondering what an Ising spin is, the Ising model, named after the physicist Ernest Ising and Wilhelm Lenz, is a mathematical model for ferromagnetism in a statistical mechanistics. The model consists of discrete variables that represent magnetic dipole moments of atomic spins that can be in one of 2 states. The spins are arranged in a graph, usually a lattice, allowing each spin to interact with its neighbor. And so, to put that into layman's English, what it means is if you have a spin state of one particular spin in some kind of atomic model, and you have another atom that's at some other angle, they'll tend to, instead of being at different angles, they'll tend to try to spin themselves together into a similar spin alignment or if they're at a slightly off angle like this, they'll tend to spin themselves into a alignment like this.
Well, like a gyroscope almost.
Right. So they're going to try to
Mhm.
align with themselves, is what this sounds like.
So
if
can
I'm
they
understanding what this is talking about correctly, and yeah, it does relate to that. If I'm understanding that correctly.
So is that Cooper pairs then for superconductivity, where they get both electrons to spin with the?
It's directly related.
Okay. I was trying to figure out. Thanks.
Yeah, it's
So
directly related. So
it's directly related to spin liquids, is what it really is. It's the same concept.
Right. So let's say you have two conductors facing. Let's say you have two conductors facing like this, and my fingers point in the directions of the electron flow. So we're not using whole flow theory; we're using electron flow. So what's going to happen is electrons are flowing up through my hand to the point of my finger, and in that direction, and then they're, moving continuously. My two fingers will push apart because the electron flow moving this way, and the electron flow moving this way, are in opposing directions. The spins of each electron flow with their orthogonal magnetic fields. As the electrons flow up this way, they follow the right-hand rule, and they'll considerably rotate. So the two spins are basically pushing against each other. We have these two concentric rotations that are trying to cross each other like this, and they push apart. If they were, sorry, other way around. So in this direction, it's kind of interesting. They'll push apart on the side, but if you move them over center, they're both rotating in the same direction. So you see how this hand is rotating like this, and this hand is rotating like this? If these two are aligned, one over the center of the other, and they're both rotating in the same direction, they'll actually pull together. But if they're on the sides of each other and they're rotating just like that, they'll push apart because they're moving in opposite directions versus the same direction. So if we have a bunch of spins, what's that?
Would that line up then be coherence, or is that where constructive and deconstructive interference comes in?
Right, you get constructive interference on the faces, and you get destructive interference from the sides. So in terms of your permanent magnetic field, you just have trillions of little atomic spins that are all aligned along the same axes. And so there is actually no magnetic field per se. You just have this net rotating electric field with trillions of tiny little electric fields that are all rotating along the same spin vector axes and pointing in that same direction. So if you go to the face of the magnetic field tends to kind of disappear because you've got spins that are counter-rotating at the face of the magnet. They're going in opposite directions from where your probe is at that very face. But if you go far enough away, all those net spins, they spread out. So they spread out, in field lines that loop around.
And that's what brings the torus back.
Right. So the field lines technically don't exist. It's just a nice way to describe it. Field lines are just one way to use words to describe the basic shape and form of the magnetic flux structure. But either way, you have these fields that affect space-time, and they're affecting the refractive index in this particular geometry. And so for epsilon and mu, they're affected in the way that a field line is demonstrated. And yes, even iron filings do demonstrate those same geometries, regardless of the fact that a lot of people want to say, you can't use iron filings because they're not a true depiction of field lines. True, technically, but they do follow that same geometry. So deal with it. You end up with this structure where you have your electric fields that are all spinning in the same direction, but no net magnetic field. So there is no magnetic field. At the end of the day, there is no magnetic field from a permanent magnet, from an electromagnet, none whatsoever. There's only this rotating electric field and the net combined motion of all the electric charges that are moving faster. So in this case, atoms, the electrons are moving much faster than the protons in terms of the amount of space that they displace in their orbitals because they weigh much less. So the protons and the electrons, even for a balanced atom that has the correct number of protons and electrons of equal number, will have the electrons moving much faster, and the fact that the electrons are moving much faster through space-time means they have a larger geometrically amplified relativistic field. And the fact that that relativistic electric field exists gives them a geometry that allows what we call the formation of a magnetic field. The magnetic field at the very fine position is called the B field in physics, and when we get out to the larger frame and we look a fair distance away from our magnet, we see the combination of all those B fields, and we call the combination of the B fields an H field, and that's what we call the net magnetic field.
So magnets are just some kind of a little pump?
Yeah, magnets are just a rotating electric field source. That's it.
So I have a question about that. So I want to put this in context of the rock situation for a moment. Now, suppose you have a material that has those attributes that you just described. One piece of material. Okay. Now, let's say you cut that piece of material up into 20 different pieces. Okay. Now you start interacting these pieces of material together. What do you suppose?
Okay, I think you're asking the classic question of if you slice a long magnet. Let's say that this straw is a magnet, and this finger is north, and this finger is south, and we slice it in half, and now what happens? Now these two pieces, they don't want to necessarily stick together in the same formation, right? So you're asking about what happens when you actually divide up something that already has a spin orientation. Is that what you're questioning?
Okay, I guess I'll put it into context. I suppose you haven't seen the episode where I talked about the rock, have you?
I've actually never seen your show, to be honest.
No. Okay.
Know who you are? I'm sorry.
Oh yeah, no, I'm Joe. I'm on the channel every so often. I'm a little out of my mind, and I'm totally wrong about everything.
Well, that's okay. So am I. So
yeah,
we're in the
club. So anyway, without going into the whole thing with it, okay, I had a mineral specimen that I collected. Okay, I have a hunch that I knew what it was. I was actually didn't know what it was at the time. I was going to make some jewelry for my girlfriend with it. I go and I start taking cores out of this thing. Okay, and I'm noticing immediately that this mineral ain't right. What I mean by that is, well, I mean, it's kind of throwing static charge. It's sort of wanting to fly out of my hand, sort of wanting to cramp my hand up. It's sort of wanting to not move on its own, but if you touch the thing, it had excited moments, So I cut it into a bunch of pieces, trying to find the piece that I was going to make the jewelry out of, knowing that something strange was kind of going on with it. All right. And I put all the pieces together, and there was very unusual interactions between the pieces of the stone itself. Okay. It would lock, but then release. It would, then it would become like, it would bounce off of it like a piece of glass, give like a high ping sound sometimes, then other times it would lock, same pieces in contact with each other. Its poles, if it had them, would seemingly shift. If you rub two pieces of it together like flat surfaces like this, it would rotate, then it would stop, then it would lock. It was screwing with a piece of titanium in my wrist, like when I was handling it. Yeah. So I was like, what the hell am I dealing with? And I'm pretty familiar with rocks, minerals, and crystals and stuff, like been collecting rocks and stuff my whole life. I'm like, never seen anything like this ever in my entire life.
I'd love to give you an answer on that, but I can't.
So, well, here's what I can tell you, based on the volume measurement of it, it seems to be Hubert Smithite, which I didn't know exactly what it was, but it looked like it. And the hardness test was the same, and the density test was it was similar enough that led me to believe that it was probably that. I mean, it was in matrix, there was other stuff going on, wasn't isolated, it was a natural specimen. So, that was sort of what I came to the conclusion. And then, but I knew nothing about it. Then I start looking into it, and it turns out that they're growing this stuff in labs in fact, MIT did like a huge, basically a lecture on it, and its particular crystal lattice structure, which was it's exactly like the six-pointed star. They're all just locked into each other, and they said that it's one of the few known quantum spin liquids, so it doesn't have a predeterministic spin of any of its electrons, and that it has moments of excitement that can shift the poles depending on at random. So it's like in a continuous state of like flux with itself. They call it like like a multiferroic. It's a multiferroic spin liquid, but it's not liquid. It's solid. Obviously, it's just the spin state that's liquid. Because
Never even heard of it. I mean,
yeah,
I've never heard of a multiferroic liquid at all. That's a new term for me. So, thank you for the new term.
yeah.
That's something to look up.
Yeah, and it was, I'm telling you, as a matter of fact, it was very, very fascinating, and it had very, very fascinating anomalous effects. Very, very fascinating anomalous effects.
Sorry.
You know?
Yeah.
That's how things go over here.
Thanks for that PDF, whoever posted it.
Kutin? I don't know how to pronounce it. Yeah.
Yeah. Yeah, that material apparently has a Kagome lattice, which uses corner sharing triangles, which the Sierpinski gas is all about, triangles. So that lattice, I'm going to investigate that paper. Thanks.
All right, guys.
Weird.
It's almost 5 hours. I'm completely exhausted.
So am I. That's why you haven't been talking much.
Dude, I'm tired. I'm sorry, man. I get up at like 2 a.m. So now.
See what happens when you put the three of us together and then add in Jeremiah? Man.
There's nowhere it doesn't go.
You keep going for 5 hours.
And if you ask me, it's all the same.
Yeah.
That's what I'm a proponent of. It's all the same.
It's always like an info drop. I mean, everything becomes this big information dump that gets poured on your heads, and it's like, okay, now I'm drowning, wiping your eyes, trying to get all this weird information out of your head.
Yeah.
Like, oh, too much. Please, just you guys stop. Get onto something.
Overload.
I just think, these things go on longer, like, let's just say if we lived in the same city, went to the same job, we would still be talking the same language. But just because I think we have the same interests, time flies by, like, because it's topics, that are enjoyed being discussed, like if you talk to your neighbors about any of this, or, like, siblings, if they don't understand, or parents, or you just normal friends, but like, I don't care. Like,
I've
I don't
gotten
care.
so many people who look at me so many different ways.
It's something to remember. This book, which is probably one of the most incredible books ever written by Bentov, so simple yet so to the point. Okay, he starts off this book by saying that this book is a culmination of discussions that occurred in his living room with friends. So.
Well,
if
this is our living room.
There was a garage with a refrigerator with beer, we'd all be spending too much time there.
Yeah.
But
Nathan's garage, yeah.
Oh, dude, I got a fridge right next to me, bro. Let me just tell you, I'm getting close to pimping my garage out. I got another whole run to do of work. I just got to feel better to do it.
I hear you. It's been great. I appreciate the insight, Victor, Joe. Thanks for coming, Jeremiah. Ben, you're doing great with your experimentation. I love it. And Lulu, it's always great to hear your insights. So
thank you,
Jeremiah. Look into
Love
that.
to be here.
Connect with me at some point. Let me know what you find on that, because I'd be interested to know your take on it.
Nate's got my email if he can forward it to you.
Yeah.
Otherwise, you can check the private chat. If you've been here, I just posted my email in there at the beginning. You should have access to it. So.
Yeah. Cool. All right. I'll have Nathan send it over to me. I don't see it. I don't know. I'm stupid.
I'll post it again.
All
I'll
right,
make
cool.
sure you get it. Don't
So
worry about it.
Click on the
I
private
got it.
chat and then go ahead and I just posted it again. If you joined a little late, there it is. You see it?
Comments.
Private
Recording chat. Yep, got it. Yeah, that's easy enough, isn't it? All right, cool.
There you go.
Thanks,
Well,
man.
guys,
Appreciate
thank
it.
you, and I want to thank Sean, even though he's not here right now. He came in and did an awesome job on this.
Yeah,
circuit.
thanks, Sean.
Thank
And
you.
He's sending
Thank
me
you.
one, so I'm going to verify all of it, man. It's going to be awesome. So he wants me to run it on my gold coil just to make sure we got the same thing going on. So
Nice.
gotta love that, man. All right, guys. Thank you very much for everybody being here. I appreciate it. Have a great night,
Thank you,
guys.
Nathan.
Thank you guys in
Good
the
night,
chat.
everybody.
Thanks, everybody.
Good night.